Hack the planet! Hack the planet!
Shut up and get in.
We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, HackerFrogs, it's me, the Shy Hat, and we're doing HackerFrogs AfterSchool today. We're doing HackerFrogs free hacking. We're doing a hack of a time today on the live stream. So what are we doing today? So typically we do 4 topics on each one of our live streams, and let's review what we're going to be doing today. So topic 1 is going to be some gaming. We're going to be continuing the Witness, which is a puzzle game that I've really taken a shine to, and every Monday we've been playing some of the Witness for about an hour or so, just so we can warm up and get ourselves thinking about some problem solving. And after that, we're going to be doing HackerFrogs AfterSchool. This is a beginner's program where you can learn about some basic concepts for learning about cybersecurity. This is the last of the classes for Python basics, so the Python programming language. We're going to be talking about how to import modules into Python and then how to write our own scripts to try to solve CTF challenges, so solve little challenges using our programming skills. So the third topic of the day is going to be a Vulnyx machine. So this is a demonstration where we're going to be talking about how to hack against web application firewalls. So the challenge is Vulnyx from Vulnyx.com. It's called YourWAF, as in web application firewall, and that's going to be the third hour of today's stream. So the fourth topic that we're going to be doing until the end of the stream is going to be Dockerlabs.es. This is a Spanish language cybersecurity education website, and we're going to be doing a challenge called Fileception. So we're going to be doing some stuff with files. That's pretty much guaranteed, and we don't know anything else about this challenge. We're going to be going into it as a first-time participant. So without further ado, let's get into the first part of today's stream. So we're just going to do our gaming warm-up. Let's go ahead and put ourselves at 60 minutes on the clock and then get started. Okay, so let's get into it. So this is the Witness over here. If anybody's interested, you can save 80% off of the Witness over at Steam right now. They're having their fall sale, and it's going to be going on for the next, I don't know how many, this is seconds, this is minutes, this is hours. So for the next day or so, they're going to be selling this for about 80% off. So it's $8.76 Canadian, which is where I'm from. If you're judging it by like American dollars, it's probably like $6, $6.50 or something like that. And yeah, here's the link just in case you're interested in getting it. It's a really fun puzzle game, and it gets you thinking in some different ways. So let's go ahead and get into the game then. So the last time we played the game, we were looking at reflections. So what we need to do is we need to look at the reflections of these puzzles to try to figure out what the solutions are. So I think we can see the reflection for this particular puzzle in the water here. That's kind of hard to see. That's kind of hard to see. I think I might have to bring the water back up. So I've got a little switch here that we can push to pull the water back up. I wonder if I can see that reflection from the opposite side. Okay. Anyways, we wanna... So we saw something in the reflection here. That's a tricky one. I'm just gonna walk over here, see if we can see any of the reflection in... Yeah, we can see a little bit. Doesn't really tell us very much. Let's try sending it back down again. So we might be able to catch this at a certain angle that lets us see what the solution is. Oh man. It doesn't look like we're getting any information there. Yeah, and we can't see the reflection from these angles. Okay, let's send it back up. I'm going to try to screenshot this at a good angle where we can actually see what's going on. Okay, I see something. So I'm pretty sure I screenshotted that. Let's see if we can view it from another angle. Okay. Nothing's really there. Is there another good vantage point we can see this from? No. I guess we send it back down again then. Actually, before I do this, let me take a look at my screenshot to see if we got anything good. Oh. Looks like we didn't screenshot. Hold on. Sorry, I forgot to start up my screenshotting program. Let me try that again. Okay. Man, that is really hard to see. Okay. We'll send it back up. Okay, I think this is a much better angle. Okay. Took that screenshot, but unfortunately we can't see anything from the other angle. What happens if we look at it from this angle? Let's send it back down. Sorry, there's going to be a lot of experimentation over here. Can't see a dang thing. Okay, so this angle is no good. Don't think I can see it from this angle. And this is a bit too far away to see anything good. Let's try looking at it from up close. Okay. Reflections coming up. Does it show us anything? Nope. It doesn't show us a darn thing. Now, what are some possible places we can stand from to take a look at this thing? So we solved this part over here, and let me just move on over the other side. So we got this part over here. We're assuming that we're going to get access to this part after we solve this one puzzle. Let me take a look at the screenshot that we took. So, just a second. So the screenshot that we took looked kind of like this right here. It lets us know that we need to start from the corner and then go diagonally down and then up and then down, and then to get the other side, we don't know what is happening in here. We could try brute forcing it. Brute forcing it doesn't feel like a good. It doesn't feel too good, but we can give it a try. Okay. So we have to start from up here. Then go. How does this make sense? Because this is mirrored. We have to go this way, and then diagonally that way, then to the center, and then this way up and then out? No. Okay, so let's try a little bit of brute force. We could go down and then back up. Okay. Anyways. Sometimes brute force is better than not solving the darn puzzle. Okay. Now what's over this way? More of this stuff. Okay, so we see some interesting patterns here. So over on the left-hand side of the screen, we see some reflections and some scratches. Let me take some screenshots, because we're going to be using these later. So this is just an S shape that goes down. Okay, let me take another screenshot of this thing. This is very, very easy. It's very, very easy to see the solution here. Okay, so I'll take a couple of screenshots. It just goes straight and then takes a little turn, and then it goes all the way down to the bottom. Okay, so that's that puzzle. What about these other ones? Okay, I see some patterns in the reflection here. Oh, this is a mirror. Okay, so we got a mirror. Let me take a picture of this part. Then I'll take a picture of the mirror portion. Okay, and this is also a curved mirror. What is going on this side? So we probably need to follow this pattern over here for one of the puzzles. Oh, okay. Yeah, this is... I guess we can look through this pane right here. We also have this puzzle. I don't see any reflections from any of these angles here. And I don't see anything in the mirror either, which is kind of unusual. I think the lighting is going to change after we solve a couple of these puzzles. And it'll help us to see what the correct path is. Okay, so looks like an elevator up here. We're getting pretty close to the end of this section, or at least I hope so. So this is the first puzzle. I mean, I think I can just memorize this. So it starts at the top, goes down one, and then continues until the second to last, and then goes down. Okay. Okay, and now we can solve this one. This one is make an S shape and then take it all the way down to the bottom. Make an S shape all the way over here. Okay, and then this one is I mean, I'm not exactly sure what's going on at the top. It looks like it's coming down. So it's like this. But I'm not too sure what's going on down here. It looks like... this is my best guess. No. Okay, so what's going on at the bottom there? Oh, I see. Okay, so it's making a like a four square shape, and then it goes up. All right, let's try this again. So something like this. Then we make this 4 square shape, and then go down here. Okay, cool. All right, what's the next one? Oh, it looks like we're getting on an elevator. So we still don't know what the solution to this puzzle might be, because I can't get an angle on this that shows me the right places to draw on. Okay, let's try going up to the elevator. So we can't actually use the elevator right now because we've got this one part that's stuck. So do we need to solve... Oh, I think we need to solve this one as well. But I don't know what the pattern might be. I guess we could take a look at... this. The shadows. But the shadows don't really tell us too much either. I don't see any scratches on this. We definitely need to start here and make some sort of pattern, then go up to the top. But I really have no idea what the pattern would be. I guess we need to avoid... We need to avoid these obstructing pipes. So it'd be up, and then I guess we would also need to avoid the beams or the planks over here. I've got no idea, but it does look like this is powering the elevator. Let's try looking in the mirror. Okay, so the mirror... Oh, interesting. I see a pattern. I see a pattern. Let me screenshot that. Yeah, it goes all the way. Yeah, that's a pretty complicated looking pattern. Shota Fujimori, hello, nice to see you here. We're just playing some puzzle games right now. We'll be getting to the hacking in about how many minutes? About 40 minutes or so. Okay, so let me show you the screenshots that I took. So the latest screenshot that I took is where? It's this one. So I'm going to try to follow this pattern. So it looks like we go right. No, we go left and then to the corner. Left and then up to the corner and then make a staircase all the way down and then go to the exit. Okay, let me see if I can follow this. Okay, so here, oops. So we go this way and then up to the corner. And then we make a staircase that goes down. And then after the staircase, go up to the top, and then over here. Man, second the mind. Yeah, I got this. Thank you. But thank you very much for coming by, and welcome to the stream. Hey. All right, so we can use the elevator now. No, we still can't use the elevator. We need to solve the other puzzle. Good day to you, second the mind. So we just need to figure out this puzzle. But this puzzle, there's no good angle that shows me what the pattern would be. Usually there's something in the reflections that'll show you what the path is supposed to be, but I don't see anything for this one. I've also been taking a look at the stuff in the reflections in the mirrors here, but the mirrors don't show me anything either, or at least I can't get a good angle on it. Oh, okay, I can adjust the angle of this thing. So what does this do? Oh, that changes the angle of the light. Okay, so I see something here. Let me take a screenshot of this. Alright, let's try adjusting it the other way then. We're looking out for those patterns. Okay, we see the same... So it looks like it should be really, really easy. So it's going to be bottom left, and then go to the center, and then over to the other side on the bottom. So it goes bottom left, and then to the other side, and then like this. Alright. Now we can use the elevator. Where is this taking us? Are we finished? Please tell us we're finished. Does this take us to another building full of puzzles to do? Oh no, wait. Is that the laser? Yeah, we're finished. Awesome. So this is going to very slowly rotate and then fire the laser up over at the peak. Just have to wait for it to slowly rotate. Okay, so it's shooting its laser. Alright. You know, before we move on, I really want to check out this building over here. Or is that a building that we came from? My memory is so bad. Yeah, okay, we finished all these. Alright, cool. We're done with this area. So, which areas have we not covered? I don't even know anymore. I'm gonna have to wander around. So we finished that area. This one points to... I was assuming that all these lasers point to the same peak, but this one is pointing at a different place. Maybe I'll follow this light and figure out where it's going. Okay, let's just keep on running around. Where is it going? It's going like across the ocean. That's... I don't think that's a place I can go to. Anyways, let's get to the bottom. And I think there might be a bunch of puzzles over at that peninsula there. Oh, that's where I came from. This is the beginning of the game. Okay. So I've already solved these puzzles here. I'm just trying to figure out which areas of the map I haven't discovered yet. What is this? Cryptic patterns. Okay, so we just finished this part of the island. I guess we can just keep on following the coast, and it'll bring us to newer areas. Or at least that's what I'm assuming. It's a tree. Some lasers. Okay, so maybe this is a new area. What is that? Well, let's go and explore down there. Do we have a way down? Nope, no way down. Can't even tell where I've been anymore. Can't jump down from here. This looks like a place with puzzles. Okay, so we can't solve this puzzle because parts of the puzzle are blocked off. We're gonna have to find some way down to the bottom there. Looks like there's a gate, and the gate is through the area on the other side with the orange trees. How do we get there? I guess we need to go down. We're still trying to find some way to go down to the bottom there. See if we can find a way down. Not here. Are there any... There are no ladders that lead down. This doesn't lead down either. Can't do anything to these panels here. Maybe we need to take the boat. We might need to take the boat over there. Can't remember the last time we saw like a place to get on the boat though. ZG, hello, nice to see you here. Welcome to the stream. We're just lost. We need to find our way back to where the puzzles are. Let's see, we did all these already. I think we can take the boat from over there. Okay. Let's call the boat. There's a boat that comes up from the ocean. Okay, so we'll take the boat a couple of stops. So we are... ZGZ says, I started to make the CTF all this up. I thought it was going to be easy, but it's so complex. I think it's because I'm new in these things, but I'm trying my best. ZGZG, you were trying the introduction challenges, right? So for the introduction challenges, which category did you try? Okay, so I think... Where do we think we are? Honestly, I don't know. Oh, okay, so we're here. So we're here. Let me try taking it over to this landing spot. And we'll choose to go as fast as possible. Thank you. This is going to take a little while, everybody. But do you have any good jokes? And if you don't have any good jokes, you can talk about cybersecurity stuff, because, you know, I'm here to teach cybersecurity. Alright. So we can check out the scenery here. We're trying to get to the area near that warehouse and the area where there were all the orange trees. So I'm going to look out for that. Okay, so we've seen all this stuff before. I think this is definitely going to be... ZGZG says, I didn't start with the introduction challenges. I started with the challenges you were solving and tried to solve it. ZGZG, are you talking about the binary, the software hacking challenges? Software hacking is it's kind of advanced. As far as, like, getting into... Sorry if English is not too good, it's not my first language. No worries, no worries. Okay, so this is definitely where we want to get off. But ZGZG, were you doing the software hacking challenges? Or were you doing something else? And I gotta ban somebody that is spamming their viewbot link. Can we not get off here? I don't think we can get off here. Irony that it's a bot as well. Just a second, everybody. I just need to get in here and do that ban. Okay, that's done. Let's, I guess we haven't unlocked the pier yet, so we can't get off here. So let's try going to the next spot. So the next spot we can go to is this one. Okay, gotta increase the speed. Yeah, can't fast travel to that place because I haven't unlocked it yet. It's a bit disappointing. ZGZG says it's the WEP hacking. WEP, okay. And the network security stuff, but the network is so hard and complex, more than WEP hacking. Are you talking about, what is it called? Wireshark? So the Wireshark challenges with the PCAPs? Shota Fujimori says, "Are you playing Minecraft?" This is not. It's not Minecraft. It's a puzzle game. It's called The Witness. So I'll give you. So just look up. So the name of the topic is in the upper left corner of the overlay. Yeah, Wireshark can get a little bit complex. Okay, so we can... Yeah, we've been here before. Or have we? Let me check it out. I don't know if we've been here before. And if we haven't been here before, we can solve some of these puzzles. So what does this star thing mean? Does this mean... I still don't know what the star thing means. Oh, we can't pass between the star? we can't pass between the star things. So this works, and this works, but we can't pass between them. Otherwise, it'll reject this. Okay, so we got a whole new slew of puzzles to do for the next 20 minutes or so. So we need to... Okay, it looks like we need to touch the boxes. No. How are these symbols interacting with each other? ZG says, "I'm sorry if I bothered you." No worries. You're not bothering me. It's fine. What are we talking about? We're talking about Wireshark. So the network, try the challenges in the introduction section of the website, and they should give you a lot of information about how to solve the difficulty of the challenges. Should be easy, and you should be learning from each one of the challenges. So start with the introduction ones. So this says that both of these are not fulfilled. So do we... If we don't interact with the symbols at all, it also doesn't let us through. So we need to... In the Cloud says, Wireshark is awesome. Currently crafting packets and analyzing with Wireshark. Fairly fascinating. Yeah, I would like to do like a deeper dive on Wireshark in the near future. Maybe in a few weeks. So what do we need to... What is the rule? Okay. Let's go back to the original puzzle. So the original puzzle here, we're touching the squares with the symbols, but we're not moving between them. So we can't move. We need to touch the squares, but not go between the squares. So I mean, not going between the squares is impossible here. So we can go here and like this. Yeah, okay, it works. So we need to touch the squares, but we can't go between the squares. So touch the square, but don't go between the squares. Okay, and now we've got another one. Touch the square. I guess we need to go this way. Wait, why does this work? We didn't touch this square. So what's the rule? We just can't go between the squares? We just have to not go between the squares. So there's got to be a contiguous, like a path from one square to the other that's not broken. Okay, let me try to figure this out. We solved this puzzle. So if we just... Okay, so that, yeah, so we just can't go between those squares. Cool. Let's continue. So we just need to go around the outside then. Wait, how does this break the rule? Because I'm not... So is this a rule that if the squares are... I mean, it could be a straight line, but what's the logic in that case? Is it because there's two sets? It might be because there's two sets of these star squares. So there's one set here. Okay, so if there's two sets of the star squares, it's okay to... So they need to match with each other. This doesn't work. That doesn't work. So like this. So there's a set of 2 and a set of 2. Okay. Yeah, 2 each side. So they each need to have a matching set of 2. Okay, so in this case, we start here. We need to somehow end up over there, but there are all these broken... So there's 2 sets in this case. So there's 2 sets. This works. Now... So this will be one set, and this will be the second set. Okay, now there's 3 sets. So if there's 3 sets, we need to make sure that they are each paired off with each other. Okay, wow, how long is this bridge? Okay, 3 sets. So there's 2, there's 2, and there's the last set of 2. Okay, cool, cool. Now there's 1, 2, 3, 4 sets. So here's a set. That's 2. No. That's 2. How do I do this? Nope, that doesn't work. This separates... Man, there's gotta be some... So up like this. Like, no, this is this was so close to working. Maybe like that. But if I go up here, then I have to cross over here, and that doesn't give me a way to escape. Man, so close. Oh, like, this doesn't work either. Maybe, like... Oh, man. So close to working. Okay, so... Isolate up here. No. Too Fat Show, hello, nice to see you here. Welcome to the stream. We're just trying to figure out how to solve this puzzle. If you have a solution to the puzzle, and you're free to give it, especially if I seem to be struggling, and I am struggling right here. Okay, like this. Oh man, this comes pretty close to working too. So if I'm able to separate before I go down, separate the ones on the left-hand side before I go down to this area here, then we could solve it. Okay. But I can't go all the way up here. Fameless, hello, nice to see you here. 2 up, 2 left, 2 up. Okay, let's follow your instructions. 2 up, 2 left, 2 up. 1 right, 1 down. 1 right, 1 down. What was it? 1 right, 1 down, 1 right, 1 down. So we can't cross any of the paths that we've done already. Otherwise that would be an okay solution. Brian's, hello, nice to see you here. What is up? We've just we might be stuck on this puzzle for the next 10 minutes. Who knows? So this isolates these two if we can cross like this. Let's try something a little more abstract. Like this. So that's 2. But we can't... ZG says try 2 left, 2 up, 2 right. Okay, so starting from the beginning, we do 2 left, 2 up, 2 right. Okay, so we can isolate these two, and then Unfortunately, this doesn't work out too well. So here's a pair. So if here's a pair, and then we can't block this off. Because this has to be 3 at this point, and that's not going to work. Yeah. Unfortunately, it doesn't work because we can't cross over lines that we've already been to before. I mean, I'm thinking that we might have to start zigzagging around, but So like this, that's 2. And then oh man, I wish we could get something that we've got all this space over here. Something like this. This comes pretty close. Okay. Isolate here. We can't isolate like this. We need to... like that? No, that doesn't work either. Okay, so this isolates those 2. But the problem is that these 4 all share territory. This doesn't work either. The good thing is that we're only gonna be doing this for the next 5 minutes or so. Then we can move on to the next part of the stream. Okay, so that's 2 down. It's another 2. No, but we got 4 sharing territory here. That's 2, that's... How about like... Does this help us in any way? If we got something like this? No. No, it doesn't. How about like that? Okay. What a mess. That's 2. That's... we can't... Huh. And then we got 4 sharing territory here. It feels like I've done all the permutations, but I'm pretty sure there's got to be, I mean, if I did all the permutations, then I would have figured out a solution. This doesn't work. That's 4 of them all sharing territory. This is also 4 of them sharing territory. Famous says, I think the problem is the middle star. We need to first get it solo. So the middle star, we're talking about this thing. Yeah, I mean, if only we could get to the middle here and then separate this stuff, but we can't. We can instead go this way. But going this way isn't going to work because if we try to separate it like that, then we have to end up moving in front of our exit path, and that will never work. Wait, is this it? Did I stumble upon the... Oh, no. This doesn't work because I've got the ones at the bottom. Wait, can I adjust this? So... Yeah, this solution doesn't work. Okay, everybody, we're gonna have to come back to this next time because we have to start up our class. But if you're here and enjoying the witness, then let me tell you how to get it for yourself. So right now it's on sale on Steam if you want to pick this up for something like $6 American, maybe a little bit more. Here's the link. I don't get paid by Steam, of course, but if you want to pick this up on your own, then you are very welcome to it. It's a really cool game, and some of the puzzles are very, very difficult. But with that said, let's go ahead and move on to the next part of the stream. Okay, we can get out of here, quit. And we're going to be doing our Python lesson. So let me go ahead and change the topics. We're doing topic 2, topic 3 is on deck. And let's get into it. I'll put 60 minutes on the clock. Hopefully we don't need the whole 60 minutes. We will see. All right, let's, don't think we need to play any music while we're doing this portion of the stream. All right, it's time for HackerFrogs AfterSchool Python Programming Basics Part 8. So this is the last session we're going to be doing for our Programming Basics with Python course. And let's talk about what we're doing today. So what we learned before. So this workshop is the 8th and final class for Intro to Python Programming. During our last workshop, we learned about a few programming concepts through Python, including the following. We learned about dictionaries. Dictionaries in Python are similar to other container objects, such as lists, except that the data stored in dictionaries are pairs of keys and values as opposed to individual items. So dictionaries are useful for recording different key value pairs that all pertain to one subject or one common value across a number of subjects. So for example, if you wanted to have a bunch of keys and values that all talk about the same topic, for example, there might be vital statistics for a person. You might want to keep these inside of a dictionary. In this workshop, we're going to be talking about the following things. We're going to be talking about modules and packages. So we'll just cover enough about modules to figure out how to get them going. We're not going to talk a lot about how to create modules, more about how to use modules. Okay, so let's get started. So what are modules? So in Python, a module is a piece of software that serves a specific purpose. Modules typically contain a number of functions, classes, variables, and/or methods, which can be imported into a Python namespace to make use of extended functionality. So what are namespaces? So a namespace is a collection of defined symbolic names and their corresponding values. Every Python program exists within a namespace, and importing modules into a namespace adds objects from the module into the current namespace. So for example, if we go over to our Linux terminal here, we can start up our Python interpreter. And we can import something. So import, let's just say we want to import the sockets module. Oh, the socket module, socket. So import socket. That means that everything inside the socket module, it's a module for communicating over a port and connecting with a remote server. So now that we've imported it, we can use the functions and the methods inside of the socket module and do a bunch of stuff. So this means that everything from the socket module has been imported into our namespace. So the thing is that you have to be careful when you're importing modules into your Python projects, because if you're not careful, there could be a namespace pollution, and that's when there's more than one function or more than one variable that's named the same thing, and that's never good. So how can modules enhance our Python programs? So as an example, the Python random module contains a few different methods for generating random numbers and/or rearranging pre-existing data into random configurations. So import random, and then we've got a number list. We do random.shuffle on the number list, and then when we print the number list, we see that the order that the list is in has been modified. So we can go ahead and try creating this ourselves. So Python, onlinepython.com. This is the website that we like to use for our demonstrations over here. So it's not it's good in a pinch for doing some Python programming. You don't necessarily want to do a lot of long-term projects inside of web apps like this, because it doesn't really save your progress. So what do? Import random. We create a number list. So numList equals a list. Let's just put some numbers in here. 1, 2, 3, 4, 5. And then we want to do something with the random module. So we can give random.shuffle, and that'll access the shuffle function inside of the random module. Sota Fujimori says, thank you for your streaming. I have to go. See you soon. No worries, Sota Fujimori. Hope to see you again. And let's give you a fun video redeem to see you out. How about a Nyan Cat? See you next time. Okay, so if we random shuffle on the num list, we can try printing those out at 2 different points in the program execution. So we'll print the num list here before the shuffle takes place, and we'll also print it out after the shuffle takes place and before the shuffle takes place. It's going to be the same command, we're just printing. Let's go ahead and run that. So we see here that the original order is in the first print and the modified order is in the second print. So like it says, it's going to shuffle the list around so that it's got a different order. So if you run this multiple times, you're going to see that it should be different each time. So 1 5 2 3 4, 2 3 5 1 4. Okay, so we're using functions and features from a different code base over here. So in order to use the module functionality, the module must be imported into the namespace. So this can be done in one of two ways, either by importing the whole module into the namespace as shown above, or we could do it another way. So import random imports everything from the random module into your namespace. We can actually specify specific functions to import as well. So this is this can be very good if you know exactly which part of the module you're going to be using. We can specify which methods or functions to import from a specific module. For example, this over here. So from random, import shuffle. That means that we're not importing the entire module, just the shuffle function. So we can do that over here as well. Okay, where are we? So instead of import random, we're going to do from random import shuffle. So that's going to mean that not everything from the random module has been imported, just the shuffle function. And that means that when we use the shuffle function, we just need to type in shuffle instead of random.shuffle. It does the same thing. So if we run the program again, the functionality is about the same. But the good thing here is that we didn't import a bunch of stuff into our namespace. We just imported one function. So now that when we import specific functions from a module, we can access those functions without specifying the module name, like we did in the first example where we used random.shuffle. Okay, so let's talk about a couple of pretty common modules we use when we're doing CTF challenges. So the Python socket module can be used to connect to and interact with networking ports on remote servers. And the Python requests module can be used to perform web requests and obtain data from websites. So they're both pretty commonly used. Let's learn how to use the socket module to solve some CTF challenges. Okay, so what do we got? Okay. So if we want to practice connecting to websites, usually it's a bit of a problem, because if we use something like this, the online Python website, this Python code can't make contact with other remote servers. So, but what we can do is we can use the picoctf challenges, and within picoctf we can use the Python modules, the Python scripts from the web server, from the web, what is it called? The web shell, and then we can use it to solve challenges. So what we want to do is we want to log into our picoctf account. If you don't have an account over there, you can make one at this link over here. So let me log in. I think this is this my, I think my account here is called the Shy Hat. And let me grab my password. Just a second. Okay, and are we now logged in? Cool. Okay, we're now logged in. Okay, so after you're logged in, we want to make use of the web shell. So when you're logged into PicoCTF, you can click on the practice button, and then after you click on the practice button, you're going to see a button on the... Jeffy, hello, nice to see you here. Welcome to the stream, and thank you for subscribing on YouTube. So there's going to be a button on the right-hand side of the screen called Web Shell, so you can click on that. And wow, thank you very much for becoming a member over at YouTube, HackerFrogs Silver. Thank you very much, Jeffy. Okay, so we've got our PicoCTF web shell, and what we can do after we've logged in, you're going to see a prompt over here, your username -picoctf at web shell. You want to click on this button over here. Beside the help button, it's labeled pop out web shell terminal. So this is going to put the web shell terminal in its own browser tab, and it's also going to make it so that you can see the web shell nice and big, and this is the way we want to do it. Okay. Jeffy says, thank you for all your teaching efforts. Thank you very much for the membership. I very much appreciate that. Okay, so from here we can clear the screen, and then we can see in here we've got some files. Aside from the readme.txt file, there shouldn't be anything in here if you're not actively solving a challenge. So there's some leftover files in here. I'm just going to remove those, and we're going to be solving some PicoCTF challenges and writing some Python scripts to do that. So let's go ahead and see what the first challenge is. So this is what we're going to do. We're going to use the web VM, which is the PicoCTF web shell, to practice using Python. So we'll be using PicoCTF to practice solving their CTF challenges with Python. So what is the first one here? Well, let me grab that link. I'll paste it in the chat, and let's take a look. Oh, this is the glitch cat challenge. So our flag printing service has started glitching. Additional details will be available after launching your challenge instance. So okay, so after you've opened up your web shell in the larger view, we're going to go over to this challenge over here. It's called glitch cat, and we're going to launch the challenge instance. So after we launch the challenge instance, we're going to see that we've got about 15 minutes or 20 minutes to solve the challenge. Thank you very much for following Cadut WS. Thank you. Thank you for following on Twitch. Okay, so it says our flag printing service has started glitching, and we've got a server, and we also have a port that we need to connect to. So this is normally a challenge we would solve using netcat, but we can also solve this using Python because we're trying to practice using Python. So this is what we're going to do. So we got our information over here. We're just going to copy it. Then we're going to go over to our PicoCTF web shell, and we're going to create a Python script file. So we're going to do Python space, and then we'll call this glitch.py because the name of the challenge is called glitch cat. So we're just going to hit enter. Oh, we're not using Python. We're editing a Python file. So we're not using Python. We're using Nano. Nano is the text editor. So nano space glitch.py, and then we're going to start editing a file over here. So we copied over the command that we're going to be using to contact the server. So this is a netcat command. This is the name of the server, saturn@picoctf.net, and this is the port we need to connect to, which is 62615. So the first thing we're going to do is we're going to import the socket module over here, and then we're going to create a couple of variables. So we know that the server is going to be this right here, saturn.picoctf.net. Because this is a string, we need to put it in between some double quotes here. And we could put it between some single quotes as well. That's not, either one is fine. And we're going to specify a port, and the port is going to be this one over here, which was specified when we started the challenge. So after this is done, we don't need this information anymore, so we can just, well, we can comment it out just to keep it around. Okay, and I think I've got the script that we need to create on the Pico CT. Sorry, the HackerFrogs session notes. Let me go ahead and get those. HackerFrogs AfterSchool. This is for session notes. Batch 1 Python. This is session number 8. So everybody, all of the links that we're going to be using today, they're located at the GitHub page over here. Okay, socket and request modules for CTF solving. What's a netcat challenge link? Socket connect Python script link. Socket connect.py. Okay, so let's take a look at the. So this is a script that I created earlier. It's basically a script that connects to a specific server and port, and then we've got an output file that we create afterwards. So let me get this. I'll give everybody a link to the Python file here. Okay, so I think, all right, so let me go ahead and copy the script. So you can go over here and select copy raw file. Copy raw file. Ah, right. So after that, you're going to see the contents of the file. We can copy the entire script here. Then we can go over to our web shell. And in the web shell, we're going to paste in the entire script. So paste it in. Okay, so we've got a couple of duplicates over here. And we got server import, and we got output file. We're going to get rid of this import socket again because we don't need to repeat that. So the server import we defined up here, we can get rid of, we can get rid of this, the server and the port, down here in the script. And let's get rid of this part of the script as well. Okay, so before we run this, let's talk about what the script is doing. So we got the socket module here. We're making pretty heavy use of this when we're doing this challenge. The server here is saturn.picoctf.net. We've got a port number here, and we're going to be creating an output file. So after we finish running the script, we're going to have a file called socket response.txt, which is going to have everything that we received from the server. We create over here. We create a function called connect to server. So connect to server takes in 3 arguments. So the server, the port, and the output file. So we've got these 3 things that we need to supply to the function, and then we create a socket object. So we talked about classes in the previous lesson, and this is an instance where we're going to create a socket object. So our socket object in this case is going to be called client socket, and that's going to be socket.socket, socket.afnet, socket.sockstream. So this is how we create a socket object using the socket module. So the rest of the function over here is going to connect to the server. So we're going to do some more socket functions. So socket client socket.connect. Remember that whenever we're using the socket object, we need to refer to it by name. So it's client socket.connect. This is going to connect us to the server and port, and then we're going to print out a little message, connected to server on port something something. And then we're going to create a file that we're going to be writing to with open output file in write, and I think B is for binary mode, as file. while true, we're going to receive a bunch of data from the socket. So receive data from the server, data equals socket, client socket.receive. We receive a number of bytes of data, in this case 1024. Okay, but if we don't receive data from the server, then we break the loop, and then we write the received data to the file. So file.write that data, the data we receive. And then print the received data to the console, print data.decode to UTF-8. So while we're running the script, we will see what is being received from the server. Then we print out data successfully received in output file, which is going to be the what was it called again? It was called socketresponse.txt. Okay, and exception as E, an error occurred. So what we're doing here is we're doing a certain style of, what is it called? A certain style of loop. And in this case, we try this action over here, but if that doesn't work and we get an error, then we raise an exception with this over here. And then at the end of the loop, we will close the socket. So client socket.close. So this is another function. And at the very end of the script, we just run the function that we wrote. Connect to server, server port output file. Okay, so if we save this file here, what it's going to do is it's going to connect to the server, this one right here, on this port, and it's going to create this socket response.txt file. It'll also print out all of the data that it receives from the socket. So let's go ahead and run the script. So Python, and then the name of the script, glitch.py. Okay, so we connected this to the server on the port, and we received this, picoctf glitch me not plus this over here. So this is, well, we received part of the flag normally, but we also received part of the flag in this funny notation right here. So the interesting thing about this notation is this is actually Python. So these are Python functions that we can run. So the chr function is going to take in hexadecimal input over here, and it's going to turn this into an ASCII character. So we can run each one of these. So for example, we were to copy one of these, and we were to run the Python shell, and then paste in this. We could print this out. So print, and then wrap this around. Sand of Ice, hello, nice to see you here. So this is actually the 9 character in ASCII. We could actually take all of these right here and let's see. So what is this? This is okay. So we can copy everything from the CHRs until here. And we can copy all this. Then we can turn this into a print function. So print, and then the parentheses, and then paste in everything here. Afterwards, hit enter, and this gives us the rest of the flag. Each one of these functions is going to print out a single character in ASCII, which is these ones over here. So we can just grab the part of the flag that we have, copy that, and then paste it in here, and then grab this part of the flag, copy that, and then paste it. And the last thing we need to do is we need to add the closing squiggly bracket here. So this is the entire flag. So we can copy it all, then go over to picoctf. We can paste in the flag and click on Submit Flag. And that finishes the challenge. Okay, so the other thing about the challenge here is that, let's exit. We created the socket response.txt file, So this is so that we have something that we can refer to later. So if we take a look at the contents of the socket response, this is the information that we received from the server. Okay, so let's do another challenge. How much time do we have? Oh, we've got a lot of time. Okay. Okay, let's do this next challenge. It's called what's a netcat? So I'll copy the link. So what we need to do is we need to get used to using Python to solve challenges, and we need to get used to writing Python scripts. So this is let's see. So the next challenge is over here. Let's paste in that link. Okay. So the challenge is called what's a netcat? So using netcat or NC is going to be pretty important. Can you connect to this over here at this port and get the flag? Okay, so all we need to do here is we need to copy and paste. So we're just going to copy everything here. So this is the server that we're going to be communicating with. This is the port, and we're going to be using the same script we used before. So we can go back to our web shell. We can nano to edit glitch.py. Actually, let's go ahead and rename this. So glitch.py, we're not doing the glitch challenge anymore. We're going to rename it. We're going to rename glitch.py to netcat.py. I'm not too sure. It's called what is a netcat, right? How about we call this whatcat? So after that, we're going to go in and we're going to edit this. So nano whatcat.py. So this is the same script that we used to solve the previous challenge. We can use the same script for this challenge. We just need to go back here and we need to grab the information. So everything up until the port number. And the good thing about this challenge is that everybody's got the same server and the same port number. So I'll just paste it in the chat so that you can take a look at it. Okay, we go back to here, and we're just going to create a little comment and then paste in the server and the port number. So we can just sub these in. So jupiter.challenges@picoctf.org, copy that. Go up to the server, get rid of what we have already, and just paste in the correct server name. And we can also copy the port number. Copy that, go up to the port, and paste in that port number. So remember that remember our Python data types. So when you're dealing with strings, you need to make sure that these are between single or double quotes. When you're dealing with integers or regular old numbers, you need to make sure that they don't have quotes around them. Otherwise, bad stuff is going to happen. Okay, so from here we can just save this. So remember, in Nano, to save it, you do Control X. It's going to ask if you want to save the modified buffer, which means to write the file. The answer is Y for yes. And then confirm the file name by hitting the Enter key. Okay, so now we've got the whatcat Python script. We can just run it using Python whatcat.py. Okay, and this is a very easy challenge. It doesn't. It just gives you the flag in plain text. So picoctf netcat mastery. We didn't use netcat. We used Python, but it's fine. Let's go ahead and copy the flag. We copy the flag here. I'm pretty sure that the flag is the same for everybody. And we can see that the response has been recorded in the socket response.txt file. Yeah. Okay, so let's go over to picoctf. We'll paste in the flag, submit the flag, and then we're finished with the challenge. So we're using Python to get some specific goals done. In this case, we're using it to communicate with random ports on random servers and then communicating with them and getting the response. Okay, let's go back to our list of challenges. So what's a netcat? Okay, so next what we're going to do is we're going to switch over to a different Python script or a different Python module that we're going to be using. So this is the challenge over here. It's called inspect HTML. Here's the link. And let's access the challenge ourselves. Okay, so this is a inspect HTML. It's a challenge from the PicoCTF 2022 event. And the description says, can you get the flag? Additional details will be available after you're launching your challenge instance. So this is another one of these challenges where you need to start up a virtual machine to access the challenge. But before we access the challenge, let's go ahead and get the script we're going to be using today. Okay, where is it? Request Python script link. Okay, so this is the script we're going to be using to finish this challenge. Get that. You can take a look at the file over here. And let's go ahead and get the raw version of the file. So click on copy raw file. And this is the script over here. So we'll go over what the script does after we paste it into our into our text editor. So just copy the entire script. And in fact, if you want to just go directly to this link and then copy the script, highlight everything, select copy, then go over to the web shell. And in the web shell, you're going to use nano to edit the file. So nano space, what are we going to call this? web_fetch.py. So what the script is going to do, well, okay, let's start up the nano text editor and then paste in all of the script. So paste it in. So we can see here in the comment, it tells you what the script does. So this script uses the Python request module to make a web request to a specific web page and writes its contents to a file on the host machine. So when we say host machine, it just means the computer that we're currently using. The first thing we do is we import the requests module. So import requests, and then here we've got a URL, input the desired URL, and then we're going to get a output file. What name do you want to give the output file? So this is both user input. You can also code this in a way where you can just hard code the stuff in here and you don't need to type in the stuff. Either way is fine. I guess for this one, we'll just leave it as it is. Okay, and then what we do is we create a function. So the function is called fetch web page with the URL and the output file as the arguments. So we see that we've got the URL and the output file. They should be defined up here before we create the function. So we're going to try to do this. So send a GET request to the desired URL. Response, this variable is going to be equal to request.get URL. So we're making use of the request library and we're running the get function from it. And we pass the URL as the argument. Raise an exception if the request was unsuccessful. Response dot raise for status. This is another function from the request request module. Write the content of the response to an output file. So with open output file in write mode in UTF-8 encoding as file.write. So write response.text, whatever we received from the server. Then we print out web page content successfully recorded in output file. So if there's any error messages, we're going to print out an error occurred and then print out the error. And then the very end of the script is we're just running the function that we wrote. So fetch web page with the arguments URL and output file. Okay, so let's go ahead and save this file. So Control X to save the file, save modified buffer, type Y for yes. Hit enter to confirm the file name. And now we've got the webfetch.py file in here. So we can run it. Python space web_fetch.py. So we'll run the script and it'll ask us for the desired URL. So we're going to go back to the challenge page and we're going to launch the instance. So on the challenge description, click on the blue button. Okay, so it says, can you get the flag? Go to this website and see what you can discover. So we see here that we got about 15 minutes to finish this challenge. That is fine. So there's a link over here with the word website. We can right click on that, select copy link. After we've copied the link, I'm going to go over to the web page, import the desired URL. We can paste in the URL here and then hit enter. And what name do you want to give the output file? We can just type in the name of the file name we want to create. Let's call this, what was the name of this challenge? The name of the challenge is inspect HTML. Okay, so we'll call it inspect html.txt. Hit enter. And then it prints out web page content successfully recorded in inspect html.txt. So we see that the inspect html.txt file has been created. So we can just read it using the cat command. Okay, so this is raw HTML code. So you can tell this is raw HTML code because it's got a bunch of HTML tags like head and HTML language and body stuff and headers and paragraphs. So the interesting thing here is that, well, we could have accessed this on a website. So where are we? So here, we could have just put the link in a new tab, and we would have gotten this. But the thing is that if we just take a look at it on the website, we don't see the flag unless we take a look at the page source. This is probably the easier way to solve the challenge, but this whole exercise is not about the easiest way to solve the challenge. It's about learning how to use the Python tools. So over at the web shell, we can take a look at the file that we created with the script, and we see here that there is a flag inside of the HTML comments. So HTML comments are going to be between these kind of tags right over here, and the flag is everything from the word Pico until the ending closing bracket. We can just copy that, go over to the challenge, and we can paste in the flag. Click on Submit Flag, and we're finished. Okay, let's go ahead and do another challenge. Let's see, Inspect HTML challenge. We also have Scavenger Hunt challenge link. Okay, and I think this might be the last one, the last challenge we do today. Okay, let's copy that link. This is the challenge. We're going to be accessing it right now. Okay, so this is Scavenger Hunt. There's some interesting information hidden around this website. Can you find it? So this is what we're going to do. We're going to get this link and we're going to copy it. Actually, we'll do that later. So I've created another script to solve this challenge as well. Let's take a look. Web page fetch. Just a second, everybody. Okay, so we've got our webpage fetch.py script, and we've already taken a look at that. There's another script we're going to be using today. It's to solve this challenge. It's called extractlinks.py. So let's go ahead and go over to this script. Okay, so what does the script do? So this script goes through the web page file and extracts any links from it and then prints out the names of the links. Okay, so let's go ahead and we'll get the raw version of the file, and I'll give everybody that raw version. So what you want to do is you want to go over to the script and you want to copy all of the code in the script here. So just highlight it all, select copy, then go over to your web shell. And we're going to create a file called extract links. So nano space extract links.py. And then after we've created that file, paste in the code for the script. And let's take a look at what the script is actually doing before we run it. So this script goes through a web page file and extracts any links from it and then prints out the names of the links. So from BS4 import beautiful soup. So beautiful soup it's a pretty commonly used Python module that is used to parse web page information. And we're also using another module called urllib.parse. And we're going to be using a specific function. Well, we're using two specific functions. So beautiful soup is one of the functions that we're importing. The other function we're importing here is URL join. And we're also going to be importing the system module. So we're going to create a variable called base URL. It's going to be user input. Please input the base URL of the website. So the website that we're going to be scanning and getting the links from, we need to paste it in, and then we need to save it as this variable called base URL. After that, we create a function called extract links with the file path. So the file path is, let's see, try doing something. So read the content of an HTML file with open file as file. So what we're going to do is we're going to read a file. So I'm guessing that what we need to do is we need to create a file with the web page information there already, and then we're going to feed it into the function here, and it's going to extract all the links. So open that file, and then we're going to create a soup. This is what they call it when we use the beautiful soup function. The thing that we feed into the beautiful soup function is called a soup, and then we're just going to run the HTML parser on the content. We're going to get all the links. So we're going to run soup find all, everything in the A tags, the anchor tags. And then we're going to extract the links in the next variable here. So URL join base link, link.get, href, for link and links if link has an href tag, which implies that it's that is a link. And then we need to extract the printed links. So if we manage to extract any links, then print out extracted links, and then print out the links in your extracted links variable over here. Otherwise, print out no links found in the file. If you didn't give a file to the function, then it's going to print out file not found error. And if any other errors occur, they're going to print out an error occurred and then print out the name of the error. And it looks like what we need to do here is we need to run the main function. So if the length is not 2, So if the arguments for whatever Python command you give are not 2, you need to run python extract links.py, or the name of the file rather, and then path to the HTML file. So the HTML file is going to be the stuff that you saved. Or else get the file path from the command line argument, file path equals system arguments 1, and then run extract links with the file path. Okay, so let's go ahead and save the file. So Control X to save, yes to modify the buffer, and then hit enter to confirm the name. So the first thing we need to do to run this file is we need to get the web page contents. So the web page contents we're going to run with webfetch.py, and then after we've created the web page contents, we're going to feed it into the extract links Python script. Okay, so where's the challenge? Challenge is here, scavenger hunt, and we've got our URL here. You're going to right click it, select copy link, and everybody, here's the link for the challenge. It doesn't want me to... Oh, it looks like my chat app is a bit broken. Just a second, let me restart it. Okay, so there's the link. So what we're going to do is we're going to go back to our web shell. So in the web shell, we can run webfetch.py, python space web underscore fetch.py, input the desired URL. So we just copied that URL. We're going to paste it in. Nope. Where is that URL? Let me get it again. Copy that link, paste in that link, hit enter. What name do you want to give the output file? So we'll call this one scavenger.html, because the other script expects an HTML file. Okay, web page content is successfully recorded in scavenger.html. So we're just going to take a look in here. So we've got the scavenger.html file. We can read it. That sure does look like a web page. Okay, so what we're going to do from here is we're going to feed in, actually wait, there was something in the HTML file that we should pay attention to. So inside of the comments here, there's this comment here. It says, here's the first part of the flag. So it's picoctf and then up until here. So we can just copy that, and we're going to start piecing together the flag. We can go back to our picoctf challenge page, and in the flag submission field, click into it and paste in the first part of the flag. So we're going to be adding to this in just a little bit. We just need to go back to our web shell. Okay, so we've got the scavenger.html page here. We're going to feed this into the extract links Python script. Penguin, hello, nice to see you here. Wizard frog. That's a witch hat, but I guess it could be a wizard hat as well. Thank you. Okay, so I'm just I've got a special hat this month because, you know, Halloween and everything. So let's run extract links. So python space extract links.py. So it says, please input the base URL of the website. Base URL of the website is, let's see. So the base URL of the website is this, where is it? This thing right here. So just copy that. Paste it in. Okay, and it says usage python extract links.py path to HTML file. So we have to run python space extract links.py, and then we need to give a space and then the name of the file. So the name of the file in this case is scavenger.html. So scavenger.html. This is the full command. Python space extract links.py and then space scavenger.html. It asks for the base URL of the website again, so we can just copy and paste this. And it says no links found in the file. No links found in the file? Really? Hold on. Okay, so okay. It should have identified this over here, my css.css and my js.js, because these are links. Hold on, let me try that again. What I think we need to do is, I guess it might have something to do with the base URL. We'll run that again. Okay, so Python extract links.py scavenger.html. What we're going to do this time is we're going to grab the URL here, copy link. But we're going to make sure that this slash, we omit this slash right here. So sometimes when you're working with links, including the ending slash or not including the ending slash can have a difference. So we're just going to omit the ending slash there. Still says no links found in the file. I think there was... Let me take a look. It's been a while since I've done this challenge. So scavenger.html. Yeah, the script should be able to pull out my css.css and my js.js. Let me do a quick check. Okay, so I think the problem here might be that the script is looking for A tags, and there's no A tags in the file. So it's looking for, so the scavenger.html page here, there are no anchor tags for these two files, like my css.css and my js.js. So that's why it's not able to find those. I think I created another script that is able to find these ones as well. So inside the script tag and inside of the link tag. But you know what? Let's do a quick Google search to see if we could fix up this script really quick. Put in the anchor tag to see if it works. Okay, so those would be A tags. Let's put in the anchor tags manually. Let's see. So scavenger.html. So if we were to put in, I don't know, putting in the A tags manually is a bit cheaty. I'd rather create a script that works as intended. Just a second. How much time do we? Oh, we only have a few minutes left. We might have to leave this one unsolved. And okay. Because going in and editing it might take up more time than we have for this for the lesson. Let's talk about how would I try to fix this script. If I wanted to fix the script, I would probably go over to and identify that the links are actually in the script tag here, as well as the, what is the other one? The link tag. Script tag and link tag. And I would do a little Google search. So Beautiful Soup is the name of the module. Extract links from script tags and link tags. Maybe you're just checking the body tag and not the head. Okay, so I mean, we've got the good old AI over here. It's recommending that we extracting links from link tags. Link tags typically contain href attributes that point to external resources like style sheets or favicons. So I think the reason why the script isn't working in this case is because most of the time we're not looking for links inside of the header, because the header usually has stuff that might be outside of the website. And most of the time we're not paying attention to style sheets. But in this case we want to. Extracting links from script tags. Script tags usually contain src attributes that point to external JavaScript files. So in this case, we would modify the script to include all this stuff, but it's going to take way too much time to do this stuff right now, and we need to move on to the next part of the lesson. Okay, so let's go ahead and finish up the lesson, and then we'll talk about some other resources we can use for learning Python. Okay, let's review the programming concepts we learned in this workshop. So modules and packages. So modules and packages are pre-written code that can be imported into Python files to add functionality. So it's pretty much a given that unless you're writing a very basic Python script, that you're going to be importing code into your own script in order to use the functions inside that code. So the next thing the next class is actually not going to be Python anymore. So this is the end of the HackerFrogs AfterSchool Intro to Python classes, but hopefully by now you've learned the basics and you can start learning more about coding in this extremely popular programming language. So what I'm going to do is I'm going to recommend a couple of good courses for learning about Python, and let's see. A couple of them you don't need to sign up for at all. So W3 Schools, we've been using this pretty extensively on while we've been learning Python. And here's the link over here. There's a bunch of lessons that you can use to learn more about Python. They also have interactive Python coding windows that you can use to experiment. But the other course that I recommend is this one over here. Just a second, need to wait for GitHub to catch up. Well, we've got another link over here, just a second. So this goes to the same kind of thing. Okay, so for Skills for All, otherwise known as Net Academy from Cisco, it's got a couple of Python courses that are really, really good. But hold on. Let's see, HackerFrogs, Education Resources, and then Programming. Here we are. So you want to take a look at this link here. So this is a curated list of programming education resources. So most resources require a registered account to access the materials. All resources are free unless specifically noted. So these are 2 free courses for Python, and together they make up the Python Essentials course. So the first part is a 30-hour course, and the second part is a 40-hour course. They cover everything very, very extensively over there. And Penguin Burger Meal says, Netcat is free to take, but you have to pay for assessment. Yeah, I mean, you don't necessarily need to pay for the assessment. You can learn everything from the website and from the course, you don't need to get assessed. Penguin Burger Meal says, "What about Codingami? I tried it for a bit and it feels like it's more like doom scrolling. You think you understand it, but you don't." I mean, here's the thing. So let me take a look at the Python course here. So the Python course from Net Academy, it's very, very in depth, and I think it's really great. But the best way to learn about Python is to start learning how to write scripts. And this is something that it's gonna get me in trouble, but I think that it's very good to use the AI to help you learn about programming languages. So, for example, let's do a new conversation. So, I want to learn Python scripting. Write a script that connects to a web page and returns its contents. So in the script comments, explain everything the code is doing. So this is, you have to be careful. If you get the AI to write your script and you don't try to understand what is going on inside of the code, then the AI is coding and you're not learning anything. But I think the AI does a very good job at explaining what the different parts of the code are doing and explaining them in a way that you don't have to feel embarrassed for having to ask. So if you wanted to say, I don't know, so if you have this comment right here and you wanted to ask a question, why does this print function have a letter F in front of the double quote? Okay, and then you paste in that thing. So let's just say that you don't understand what this thing does. This F in front of the double quotes. You can ask the AI, it'll explain what the part of the code is doing. So great question. That F before the quotes creates what's called an F string, formatted string literal in Python. What F strings do, it'll explain what this thing is doing. It's basically taking in, you're able to put the names of variables directly into your strings. So if you got target URL here, which is this, it will put this into this place right here for target URL directly in the string. But you can do this for any other part of the code. So if there's something you understand, transpolation. I'm not too sure what the official word for that is, but yeah, hopefully that's what it is. It's really nice, to be honest. Yeah, it is very, very convenient. I use F strings all the time when I do my Python coding. But yeah, we've been finished our topic for a little while. But this is definitely, check out the courses over here. But if you want to get better at coding in Python, you have to code in Python. Start creating some scripts. Start running the scripts. You'll run into problems. And what you want to do is, if you run into problems, you can try to Google around to figure out what's going on. And in fact, if there's something that is going wrong with your script and you see some error messages, let's see. Let's just say that so I got my onlinepython.com, and say I've got some simple script like numbers. Actually, wait. Fruits. So fruits equals a list. A list, we're going to do apples, pears, apples, pears, and lemons. Okay, say we've got something like this, and then we try to print it. We run the thing, and then we get an error. So name pairs is not defined. What we can do is we can grab the error message, and then we can give it to the AI and say, what is wrong with my code? What is wrong with my Python code? Give the error message, and then it should be able to identify what the problem is. So it says the problem is that pairs is missing quotes. So you need to be careful when you're creating different variables in Python. Everything has to be the correct data type, and in this case, the pairs in this case is not interpreted as a string, but it's interpreted as some sort of keyword. But there's no keyword and there's no variable called pairs, so that's why the error occurs. You can feed this kind of stuff to the AI, and you can try to have it identify what's going wrong, and it is very good at spotting simple errors, especially the type of errors that you'll commit when you're first learning a programming language. But anyways, we need to move on to the next part of the stream. But thank you very much. Santa Vi says we old we old here. Let's see. Penguin Burger Meal says what I tend to try to do is give the AI a very specific question, not write me Halo 3 game in Unity. Some people treat it like an all-knowing, all-powerful thing. Yeah, that's not what you want to do with AI. You want to be very, very specific. When you can be, anyways. And you want to have AI go into very specific detail to solve very, very specialized problems. Sanavi says, I remember when Perl was the hacker language. When Perl was the hacker language, that must have been like over 20 years ago, because Perl hasn't been the hacker language in a long time. But don't worry about being around for that. Okay, so let's see. Penguin says, see, this thing that he did, in my opinion, makes the person not think critically, as in someone won't try to think why it's wrong. He will just copy to AI and then said. The thing is that you have to be careful when you're using the AI. It can help. It can be a very good tool for learning. It's just that you have to be careful not to let the AI do your work for you. You have to have the AI work to explain what is going on. But a lot of people think that if you type anything into AI, then you're making the AI work for you, and that you're not learning anything. I think that kind of thinking is wrong. Xenovi says AI lies and is very convincing at lying. I mean, the thing is that the more common the question you give to the AI, the more likely it'll give you a good answer, as opposed to an answer that it hallucinates. So if you ask for stuff that is not well known, the more obscure the question you're asking to the AI, the more likely that the AI is going to get the question wrong, or it's going to give you some false information in its answer. If you're dealing with very basic programming questions that it sees over and over again, it's not going to get those wrong, because it's got hundreds of examples of the correct answer for those kind of questions. Anyways, let's move on to the next topic. Thank you very much for the bits, Penguin Burger Meal. Let's see. Well, it learns from us and we make mistakes, but what you said is 100% correct. I'm trying not to overgeneralize, because using AI in your work is it's still a very controversial thing. Some people think that if you use AI, then you're not going to be able to get your work done properly. but AI does make people more efficient at their jobs. Okay, so topic 2 is done, topic 3 is here, and topic 4 is on deck. And thank you very much for the bits, Penguin Burger Meal. Thank you. Okay, so what are we doing now? So we're doing a challenge. And the challenge is from this website over here. Where is it? The Vulnyx website. It's called YourWAF, which means Web Application Firewall. So this is basically, it's a challenge where you need to deploy a machine to your virtual machine network and then do hacking against it. In this case, we're going to be dealing with the Web Application Firewall. We're going to be talking about how you hack against Web Application Firewalls, what they are, and what you need to keep in mind when you're doing testing against them. So we've got a virtual machine. Let me start up the virtual machine. So this is the type of challenge where you download the virtual machine, you deploy it to your virtual machine network, and then you put it on the same network as an attacker machine that you're going to test it with. I've already taken the liberty of creating the virtual machine, and you know what? We can play some music now because I've already finished my educational part of the stream. I guess this is also an educational part, but it's a little less formal. Start up that music. Okay, so this is the machine here. Oh, that music's a bit loud. Okay, so this is it. It's called YourWAF, your Web Application Firewall, and we see an IP address that it's located at. So we're going to be using this IP address, and we're going to be using it as the jumping off point for our hacking. Sandovi says, did you ever do DVL, the darn vulnerable Linux? I haven't done DVL. I have done DVWA, which is the darn vulnerable web application, but it should be kind of similar. Okay, so I got to do my YouTube intro and outro for all these things. Hi everybody, this is a guided walkthrough for the YourWAF challenge over at vulnyx.com. So the first thing we need to do is we need to do a port scan of the remote server, and we see here that we've got an IP address. So we're just going to be using this IP address to do our scans. So we're going to run nmap, which is everybody's favorite tool for doing network scanning. We're going to run it very verbose. We're going to run it at very quick speed, but not too quick. We're going to run versioning information and common scripts against whatever services we find. We're going to run it against all the ports, and we're going to run it on this IP address. Okay. So the reason why we run it very verbose is that we can actually get output from the program before the program finishes scanning. So we see here that we got 3 ports that we've identified. We got port 80, which is unencrypted web pages. We got port 22, which is SSH, which is remote login, and we got port 3000, and this is running a Node.js application. So Node.js is JavaScript server software, and the first thing what we're going to do is we're going to investigate port 80. So port 80 is the unencrypted web page, and we get 403 forbidden. So that's kind of unusual that nmap is going the landing page for a web application is forbidden. But we're going to go ahead and go over to the web page manually over here. So 192.168.212.15. Okay, it says unable to connect. Unable to connect, an error message during a connection to this. So what we see here is that the server tried to redirect us to a domain. So the domain in this case is www.yourwaf.nix. This isn't part of our host file, so we're not going to be able to access this domain. What we're going to do instead is we're going to copy this, and we're going to write this into our local etc host file. So we do sudo nano etc hosts, and what we're going to do is we're going to paste in yourwaf.nix, which is a domain. We're going to associate it with a specific IP address. So the IP address for our box is 192.168.212.15, which means that every time we try to access this domain, www.yourwaf.nix, it'll reference this IP address. So unless this is done, you are not going to be able to access this on your local machine. So another thing we're going to do is we're going to take the base domain over here, yourwaf.nix, and we're going to add this to the etc hosts file as well. So yourwaf.nix without the www dot. We're going to save this out, and then we're going to go back to our web browser. Bottleneck, hello, nice to see you here. Welcome to the stream. Okay. So we're going to try to reload this page from from HTTP, but not HTTPS. And we're going to see that we've identified a web application firewall. So your favorite web application firewall, mod security. So let's talk about the implications of a web application firewall on the web application that you're testing. So I've got a file I need to download right now. Just a second. Thank you very much, Astrophysics. Astrophysics, thank you very much for the follow on Twitch. Okay, so we're doing Vulnyx. Easy difficulty. Astrophysics has subscribed on with Prime, with Twitch Prime. Thank you very much for the subscription, Astrophysics. Let's give you a fun redeem. How about some, what is it? Some Devil's Bedroom.
Not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the Devil's Bedroom. Not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the Devil's Bedroom.
Okay, so let's talk about what web application firewalls are, because this is the main crux of the challenge today. So, web application firewalls are network appliances which filter HTTP requests to prevent automated scanning and common web attacks. So what does this mean? So the common web attacks that the web application firewall might protect against are things like file upload attacks, injection attacks, login brute forcing, etc., etc. A bunch of different stuff. Astrophysics says, your keyboard sounds are super satisfying. Love to see this type of content on Twitch. Studying for CPTS myself. CPTS, is that the Hack the Box certification? I hear that's a pretty good cert. Okay, so depending on how the WAF is configured, it could filter requests based on IP address, post request body data, HTTP header contents, or many other factors. So it basically prevents your requests from going through if it thinks that the requests have bad stuff in them. So in this challenge, the web app landing page implies that mod security WAF is being used. So mod security, what is this thing? So mod security is actually a very common web application firewall, and especially for Apache servers, Nginx servers, but most of the most common servers, you'll see mod security around. So when we try using a common security tool to scan the web server, we see that our requests are blocked. So we get a 403 forbidden error over here, and that's using the what web scanning tool. So if we go over to here, we do what web over on www.yourwaf.nix. Astrophysics says it's the Hack the Box cert. I would get work to pay for OSCP, but the scope doesn't really fall under my current line of work, so I doubt they would pay for it. I mean, if they pay for a CPTS, that's already pretty good. Okay, so when we run this tool, so what web, it gives us the 403 forbidden title. But the thing is that if you manually access the landing page, where is the manual page? So the manual page doesn't give you a 403 forbidden. So why does it give you 403 forbidden when you use the wet web tool? And over here we used nmap, and if we use nmap to just scan port 80 on the server, so this is YourWAF.nix. We're going to see that nmap also gets 403 forbidden. So what is the common link between WhatWeb and nmap? And what is the difference between WhatWeb and nmap and our regular web browser? Astrophysics says, "Oh, that's funded entirely by me." Well, I mean, it's a good thing that that the CPTS is not a super expensive cert. It is kind of expensive. It's still like $500, but it's not. Mojopug says the header. Yeah, that is the case. Let's talk about it. Whoops, not this. This. Okay, so when we try using common security tools to scan the web server, we see that our requests are blocked. And this is because the web application firewall is blocking on user agent headers. So by default, web security tools send a user agent header with each of their requests to identify themselves when making requests to the server. So for example, if we use whatweb, it'll send this user agent header, whatweb something something. If you use FFUF, which is another common security testing tool, it sends this user agent header, fuzzfastyoufool. And if we use GoBuster to do some directory busting, it sends the GoBuster user agent header. Okay, so how can we confirm this? So we can confirm this by doing this. So if we run whatweb, but we actually give it a custom user agent header, it doesn't matter what it is. It just matters that it's not the default one, which is whatweb. So if we send it with the user agent HackerFrogs instead, then we get a 200 OK instead of a 403 forbidden. So a common way that web application firewalls prevent automated scanning of the web app is to filter all requests that contain user agent headers with the names of web app scanning tools. So this is something that you learn when you do red teaming. When you do red teaming, they often have to deal with web application firewalls, and they have to make sure that their tools are not advertising themselves as hacking tools, because otherwise it's really, really bad. Okay, we've got an ad running on Twitch, so we're running on YouTube, and we'll go ahead and put on some birds, because I love my birds. And we'll be back in about 60 seconds. I just need to have a little sip of water and to wait for the ads to run over. Okay. Mojopug says bird, penguin, burger meal says just a question before we leave. Do you have a series of videos like this one explaining concepts as you showcase a hack? Yeah, I do. So while the ad is running, let me go ahead and get my YouTube channel. Got a bunch of different playlists that talk all about this stuff. So the Vulnyx challenges Let's see, Linux challenges, Vulnyx challenges. Okay, let me get that playlist. Here you go. So, I mean, Vulnyx is a pretty standout example, but I've got a few different platforms that I do this stuff as well. You might want to try out the Echo CTF challenges. Here's another list. Mojopug says, do you play CTFs, CTF time ones? I don't have time. So the thing about the CTF time events is that I can't use them for my channel because they don't stick around after they finish. So the stuff I cover has to be stuff that I can turn into a video and that people can access after the event is over. Okay. So a common way that web application firewalls prevent automated scanning of web apps is to filter all requests that contain user agent headers with the names of web app scanning tools. So if you're using common tools like Nmap, like GoBuster, like Nikto, all this stuff is going to get blocked by the web application firewall because it's looking for that user agent header. So we can spoof user agent headers to trick the application into letting our stuff through. So all security tools include the option to supply an arbitrary user agent header, so we can bypass this type of WAF filtering. So not in this case, we just need to ensure that the user agent value is not one on the deny list, so almost all random values will work. So we can use user agent HackerFrogs, we could use user agent Firefox, we could do Chrome. It doesn't matter. It just has to not be one on the deny list. Okay, so the next thing that we're going to do is we're going to use FFUF with the spoofing to do subdomain enumeration. So now that we know which user agent values to not use, we can fuzz the subdomain with FFUF. And okay, let's go ahead and do that. Let's see, brute force attack. So FFUF is a tool that we can use to do subdomain enumeration. We can do all sorts of fuzzing with FFUF, but it's very good for subdomain enumeration, trying to find additional subdomains after you have an initial domain. So for example, the website that we're accessing right now, where is it? You can get rid of some of these tabs because there are way too many of them. So the domain that we're using right now is www.yourwaf.nix. So www is actually a subdomain, and we can try to look for other subdomains that are not www using FFUF. So we're going to use FFUF. We're going to get a list of 1 million of the most popular subdomains. We're going to fuzz the yourwaf.nix domain, and then we're going to submit a custom user agent. Because if we don't submit a custom user agent, then we're going to find that everything gets blocked. We just need to make sure that the user agent is not the default one for FFUF, otherwise bad stuff is going to happen. Okay, so we immediately find that www is one of the subdomains, so this is our good control one. We also discover maintenance over here. So maintenance is another subdomain that we could enumerate on the web app. So these are the only two that exist, so we can just get out of FFUF now. What we're going to do now is we're just going to add maintenance to the etc host file. So we got yourwaf.nix www, and we got the regular old yourwaf.nix. We're going to add maintenance.yourwaf.nix to the list, and then we're going to save it out. And then we're going to access that endpoint. So we can go back to our web browser. We're going to replace www with maintenance. And here we've got an interesting web application. So if you don't speak Spanish, you can always Well, you can always Google Translate this. So where are we? So Spanish. Running commands. You can run commands for the server maintenance below. So this application it's running a pretty dangerous function over here. So basically what we can do is we can type in Linux commands and it gives us the output. So what is going on? Okay, so we found the maintenance subdomain. We added it to our etc host file and then we accessed the maintenance subdomain. Now we've got a new problem. So the web application firewall is also doing command injection filtering. So the maintenance endpoint hosts an OS command function, but it filters commands based on deny listed patterns. So it'll give us, every time we give something that the web application firewall doesn't like, it'll give us a forbidden message. So persona management says, I'm new to this and subdomain enumeration sounds like sorcery. I mean, everything sounds like sorcery when you haven't done it before, but after you get used to using programs to fuzz for subdomains, it'll become more and more normal. So my recommendation is to try a few different challenges that involve subdomain enumeration. You'll get used to it after a while. It is a pretty standard part of web application security testing, trying to find hidden domains, or hidden subdomains rather. Okay, so where was I? Oh, we're talking about the application. Okay. So over here, anytime we give something sensitive, so we try to lsla to get the current directory listing, it'll give us a forbidden. So what is the application actually filtering on? So this could be the web page filtering, but it's actually the web application firewall filtering. So let's talk about this. So OS command filter bypass. This is what we need to do to get access to the system. So we can use the so if we try to access bin bash, it's not going to let us. Let's demonstrate. So over here we'll go back. We'll try to run bin bash, or just try to run bash by itself. Just type in bash e something. Probably give us a forbidden because it doesn't like bash e for execute. If we specify bin user bin echo, we try to echo something out. Test. It says forbidden because it doesn't like the full file path for the echo command. But what we can do is we can do something called substitution or character substitution. And in Linux, you can do character substitution with the question mark. Let's talk about that. So we can use the question mark special characters to substitute characters in file names, which allows us to run whatever commands we want. So if we, instead of using bin bash, we do b question mark n. So because there's nothing else in the directory except for, there's no other choices except for bin and b something s something, it's only going to resolve to bash. So same thing with echo, we just need to substitute a couple of characters in there so that it gets past the filter. So the thing is that we're allowed to run, for some reason we're allowed to run the base64 command. So the only reason why we're able to actually get access to the server in this case is because they forgot to filter out the base64 command. I suppose we could also substitute the base64 command as well. We can run arbitrary commands as long as we base64 encode them first and then pipe them into the bash command. So in this case, what we want to do is we want to get a reverse shell or shell access to the system. So this is what we're going to do. Let's see, remote access. So what we want to do is we want to get a reverse shell on the target. We're going to run rlwrap with netcat to run a reverse shell listener on port 443 on our attacker system. So we got that running. The next thing we want to do is, well, we can do an experiment first, just to see if we can run a command. So we want to run a command like who am I? So if we want to get the system to run who am I for us, we would have to base64 encode it into this. So if we base64 this command, we can go into the application. We can replace bin echo with these substitutions commands here, and we can paste in our base64 encoded message. We would then pipe it into base64 decode, and then pipe that into bin bash. But of course we can't do bin bash. We have to do substitutions in here. Whoops. I have to do substitutions and -ef to execute the command. So if we run the entire command here, then we actually run the command who am I, because it was been base64 encoded and then decoded and then run by bin bash. So from here, we're going to try to get our reverse shell connection. So let me grab that command. So the command is actually this one. Let me decode it for you. Okay, so what this is, it's this command. So sh-i and then, what was that, greater than and dev device over here with an IP address and a port, and then redirect everything into standard in. Wait, is that standard in or standard out? Standard in is 0, standard out is 1, standard error is 2. But anyways, this is a reverse shell connection command that reaches out to this IP address, which is our attacker machine. So our attacker machine is this IP address right here on port 443, which we've set up with the netcat listener. Okay, so let me get the whole command. So the whole command looks like this. So we run user bin echo, echo out the base64 encoded reverse shell command, we decode it with base64 decode, and then we run bin bash to execute it. So we go to the application, paste that command in. Day asks, what's the thought process that gets us to the conclusion of using question mark for substitution? My first thought for passing a web application firewall would be to use escape characters or encoding of some kind. So I mean, it's all the way you arrive at using the question marks for character substitution in this case is because nothing else works. You can try character encoding, you can try using escape characters. Those methods don't work for this box. So you need to go down the list and do your, what is it called? Deduction. So you check off the list. Does this filtering technique work? It doesn't. Does this next one work? It doesn't. And eventually you need to arrive at this particular technique. Okay, so we run the command. And we see that the command hangs. It hangs the server, which means that it's probably in the process of doing something. If we go back to our remote access window over here, we see that we've gotten a connection from the server. So this is the server address. Actually, wait, this is not the server address, this is our address. This is the server address here. If we ask who am I, we are the www.data user. Typically what we do first is we try to figure out if we can upgrade our shell using something like Python. So we can use Python to run a command to import the PTY module, then spawn in a bin bash terminal, which gives us a slightly better terminal now. Okay, so at this point, let's call in Scary Hacker Voice Man to talk about how we broke in.
Hey everybody, it's me, Scary Hacker Voice Man. Scary Hacker Voice Man comes in every time we break into a server, and we just broke into this one. Well, Mr. YourWAF administrator, you thought you were clever by configuring your web application firewall to filter on user agent headers. That was, well, it wasn't a big mistake, but we were able to bypass it by giving our own custom user agent headers. Then we discovered your maintenance subdomain, which also had a dangerous function which lets us run Linux commands. And that was also filtered all to heck, but we managed to find a way to bypass those restrictions and then get a reverse shell connection on your machine. Maybe you knew about the security flaws in your system, or maybe you decided to accept the risk. Well, you accepted the risk. Ha 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 ha. And now we're in.
Okay, so now we're in. We just need to figure out what we're going to be doing next. So if we take a look at what we've got, we can do a bunch of different techniques for trying to figure out how to do our privilege escalation on the system. If we go over to the home directory, we can see that there's another user on the box called the tester user. We're currently running as the www data user, and if we go over to the opt directory, which has optional software, we see that we've got a node app directory in here. It's a little bit unusual, so we can enter that directory, and we see here that there's a script. There's a very conspicuous script here that's owned by root, and it's owned by the copylogs group. But there's also the code that runs the server over here at server.js. So if we read that file, we see at the top that this is a Node.js server because this is running Express. It's running on port 3000. There's an API token over here that we can use. And there's also an endpoint here called, what is it called? It's called read file. So there's an endpoint called read file that uses the API token. And what we can do is we can read arbitrary files on the web server if we use local file inclusion. Local file inclusion, the LFI vulnerability. So let's talk about that method of privilege escalation. So privilege escalation, captured API key. So we see that the server code for the app is running on port 3000, and we can capture the API key. So according to the code, there's a special function at the read file endpoint, which lets you read a file. Since the Node app is being run as root, we could potentially read any file in the system. So what we need to do is check here, ps aux. We see that the where is it? Node. Actually, grep node. Yeah, so the Node application is being run as the root user, which means if we're able to use the read file endpoint, we should be able to read any file on the system. And well, I mean, here's the thing: we don't know where the files We don't know what sensitive files might exist on the system, but we do know that there's another user on the system that's the tester user. And if the tester user has any sort of SSH keys, we would be able to read those by using privileged file read. And this is how we would do it. Okay, where are we? Let me get the command. Okay, so this is the command we're going to be using here. So we use a curl request to the application on port 3000, and the read file endpoint. So it's checking for an API token. So we supply the API token URL parameter and then the value of the API token. We also need to supply a file to read in this case. So everything here is specified in the code. So where's that code? So app.get read file check API token. Let's see. It's looking for file, and it's also looking for API token. Where is it looking for API token? Check API token. Okay, so query API token. This is where we know to supply the API token URL parameter. Okay, just a second. I need to keep my music playing. How about some really intense music from XCOM? Okay. Where are we? Right. So okay, so what we're going to do is we're going to supply the API token. We're going to supply the file. We're going to use local file inclusion escape to access the tester user's SSH key. So when we give the command, we read the tester user's SSH key. We can go ahead and copy this, and we can create our own SSH key to try to log in as the tester user. So there are a couple of steps to get this done. The first thing would be to create the id.rsa file, which is the typical SSH key file. We need to make this, we need to modify the file permissions on this because they're a bit too loose right now. So typically what these keys have to have for file permissions is just read permission for the file owner. So what we do is we do chmod 600 on idrsa. After that, we can try using this to log in as the tester user. We would do ssh tester at YourWAF.nix and specify the idrsa file. Okay, it's going to ask us for the passphrase. We don't know the passphrase, so we can't answer this question. So what we need to do next is we need to crack the idrsa key file. We need to crack the passphrase, and this is how we're going to do it. So we need to run John the Ripper to crack the passphrase. So the first part to do that is to run ssh to John, which is a utility tool, to extract the hash from idrsa. So run that and then output that to tester.hash. Okay, and then after that, tester.hash has a big hash that we can feed into John the Ripper, the password cracking program. So we run John with a specific word list, -- word list equals user share word lists rocku.txt. This is a very commonly used word list to compare against cracked passwords. To cracked passwords, rather. It has 14 million of the most common passwords on it. And we're going to specify tester.hash as the hash file that we want to test against. No password hashes left to crack. Hold on. Let me get my my command for John the Ripper. Okay, did I? Hold on. I think it might be because I've done this machine before, and it might have the hash saved. So what I need to do is I need to delete this. I need to delete the configuration file for John the Ripper. Just a second. Just a second. Let's go into the John. It's like .john or something, right? Yeah, .john. Need to get rid of the john.pot file. Okay, let's try that again. Okay, so that's trying to crack the hash over at tester.hash. It's comparing the hash against all of the passwords on rocku.txt, the really, really big password list file, password word list rather. And it's going to take a little while. So if you have any questions about any of the stuff that we've been doing so far, go ahead and ask your questions. Day says, if the password wasn't in rocku, what else could be done? We could grab a bunch of different word lists. There are more word lists than rocku.txt. Let's see. So usually what we like to do is we like to reference sec lists. So sec lists over here, we might look at different password lists. I mean, rocku.txt is a very commonly used resource, but it's not the only one. But most of the time for these quote-unquote easy challenges, the password is going to be on rocku.txt. If the intention is to crack the password or to do brute force attacks. Let's see if we can go directly to passwords. Passwords, common credentials. Corporate passwords. There's a bunch of different password lists in here. You would go down the list and try looking for some really big password lists to crack against. The last resort would be to do, like, what is the word called? It's pure brute forcing, which is trying to brute force every character in a password. It is not very efficient, and it takes a really long time. But yeah, that's something we could also turn to. Anyways, we've got ads on Twitch, so we'll also run ads on YouTube. And let's put on some birds. How about some woodpeckers? Here's a woodpecker. Alright, we'll be back in about 60 seconds. Just need to take a little water break. Okay, so we're just going to give ourselves about 20 minutes to finish this exercise. It shouldn't take that long to finish the rest of the exercise, but we're going to try to get it done in under 20 minutes because we got one more thing to do after this is all done. Okay, so this is taking its sweet time, but okay, so just to speed things up a little bit, I'll just tell everybody that I have the password. It is in the rocky.txt list, but it's really far into the list, so it might take a really long time to output if we wait for the thing to come back. But I've got the passphrase, and it is this one right over here. Actually, you know what? Let's just confirm. So cat rocku, and we're just going to make sure that the word is in the list. It's wafako. I mean, I guess it's got the word WAF in it for application firewall, so this word is in the list, but it's probably pretty far in the list. Let's... Huh. That's kind of strange. It's not too far in the list, but I guess it's taken a while. Oh, it found it. Okay, great. Okay, so we can use this this passphrase that we cracked to get into the system. So we don't need remote access as this user anymore, so we're just going to quit out of this session. Get out of here. Then we're going to SSH in. Tester at YourWAF.nix using ID RSA. Okay, what is the passphrase? It's wafako, and we're in again. Okay, I mean we've got our user flag over here. We would usually be collecting these. I'm not too concerned about collecting user flags and root flags. I'm more about the educational value. Okay, so the interesting thing about our user now is that in the op directory where the node app is, there's the copylogs.sh script here. And if we take a look at who owns that script, the copylogs group owns that script, and our user belongs to the copylogs group. So we own that script. So the other thing about this is that, well, this script over here is being used as a cron job. And how do we know that? So if we take a look at the running processes and we grep for copy logs, we see that it's being, oh, we don't see it as being run. Well, another thing that we can take a look at is we can take a look at the etc cron tab file. Is it in here? It is not in here, but okay, I know actually know a foolproof way we could figure out that this is being run as a cron job. So there's a script called psspy, or pspy for process spy. So this is a pretty common security testing tool that is able to tell you what processes are run at regular intervals. There's a binary that we need to use called pspy64 over here. Just going to download that, and then we can host it on, well, we can upload it over to the target. Okay, so just a second. Let me grab that binary. Where is it? pspy64. Okay. So I'm just going to do a very quick and dirty file transfer. Actually, yeah, this is what we should do. So we're just going to host this. We're going to host the current directory with Python. So host the server, and then we're going to download it with wget onto the machine. Okay, so what is it again? It's wget We'll move into the temp directory for this. wget our IP address. It's called pspy64. Okay, so we just need to make this executable and run the thing. chmod +x pspy64, and then run the command output to spy.txt. Run it as a let's see, Day says leaving network logs for the blue team to track down. Well, I mean, if you wanted to do this completely touchless, you can. You can do this completely touchless. And this is what you would do. So to do this completely touchless, you would just run cat on pspy64, and then base64 encoded. You would copy this entire output, and then you would paste it into the terminal here, and then redirect it into the original file name, and then base64 decode it. But I mean, I'm not especially here to talk about blue team evasion, but thank you very much for pointing that out, Day. Anyways, what were we doing? Right, so we just need to get evidence that the script is being run at regular intervals. Let's take a look at spy.txt. So spy.txt lets us know that what processes are being run. So we should see that, what is the word? What is the name of that script? Hold on, let me go back. Let me go back to the directory. So it's opt node app. Copy logs. Gakin says server.js. No, copy logs.sh. So copy logs.sh is the script we're looking for. I haven't. Let's see. Cron tab. -L, no cron tab for tester, but the script is being run at regular intervals. What day is it today? Today is, I guess the modification time doesn't really tell you either, but if you take a look at the contents of copy logs, you get a feeling that this is actually something that's going to be run on a very regular basis, because it's copying over files from the logs directory over here. But so this is our indication. So if we get the indication that this is actually a file that is being run at regular intervals, what we can do is we can just copy our own command into it. And well, and because we belong to the group owners, we can just edit this thing directly using something like nano. If we want to be stealthy, we would be adding to the script instead of overwriting the script, but in this case, we don't really need to be very, very sneaky about it. We can just run a command like this, and that's going to create a reverse shell command to our machine again. Although I guess if you were to keep this around, well, people might be able to find these logs as well. Anyways, copy that over, and then get out, start up your reverse shell listener, and 3, 2, 1, we have a root shell, because the script is running as root. Okay, who am I? Root. That's great. So we can do this.
What are you?
I'm system root.
So Gakken asks, couldn't you do crontab-e? So let me see if it works. Crontab-e. Select an editor to change. No crontab for tester using an empty one. Select an editor to change later. Select editor. This doesn't get. This is for our current user only. So so this one's not going to do the job. No cron tab for tester. Usually when we take a look at cron tabs, the cron tabs for, like, higher level users are not visible for, unless you have elevated access. But anyways, let's get out of here. Let's get our root shell back. And let's move into the root directory to get our flag. So the flag is over here, and because we've got root access, we've essentially finished the system. So I guess let's talk about how we compromise the system before we get out. Actually, let's talk about the last privilege escalation step we did. Okay, so the last privilege escalation step involves hijacking the root cronjob script owned by the copylogs group to which our user belongs. So the thing is that the cron job isn't visible to regular users, but if you take a look at the running processes, you'll see that it is being run over here by the root user. So bin bash opt node app copylogs.sh. Okay, so alright, so everybody, that was a guided walkthrough for the YourWAF challenge over at Vulnyx.com. So if you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. We're not leaving. It's just that I need to say HackerFrogs out and, subscribe to the video for my for the YouTube videos I create eventually. So if you have any questions about any of the other stuff that we did on this box, I'll be sticking around for a few moments before switching over to the next challenge. So the next challenge is going to be a machine that we haven't looked at before, and it's going to be this one over at, what is it called? Dockerlabs.es. Saint Vices almost went peace out. Yeah, it's just, you got to play the YouTube game. If you're playing the YouTube game, you have to do these intros and outros. I think the machine we're doing today is called Fileception from Dockerlabs.es. These are vulnerable Docker machines, and they're very easy to deploy to your Kali Linux machine. You don't need to use Kali Linux. I'm using Kali Linux. All you need to do to deploy the machine, to deploy the Docker container, is to download the file and then run it with Docker. It doesn't need to be Kali Linux, but it does need to be a Linux machine that you run the container on, because the startup scripts that they include with the challenge only run on Linux, or rather, they're shell scripts. Okay, so let's see, platform access. Let's move into, so we got fileception.zip. We just need to unzip this thing. And hold on. I need to properly do my countdown. So we'll do 90 minutes on this machine, and then after 90 minutes we'll evaluate whether or not we need to spend a lot more time or less time. I don't know. So topic 3 is done. Topic 4 is here, and this is the last topic. They says pretty cool. So the privesc path is basically reverse shell tester cron JavaScript. Reverse shell. It's reverse shell tester user SSH key theft, or yeah. So SSH key theft into cron JavaScript writing, or hijacking into root shell is what it is. Okay, so let's unzip this file here. Fileception. We need to make this auto deploy script executable, and then run the auto deploy script with the tar file. Oh, okay. Permission denied when trying to connect to Docker daemon socket. Do I need to run sudo on this? Oh yeah, we need to run sudo. Okay. Okay, so we've got the machine deployed now, and we're going to be doing hacking against this. So this is a lot easier to set up than the virtual machine that we did for the previous machine. So the previous machine was a separate virtual machine that we deployed on our network. This one is just a Docker container that's running on top of our Kali Linux machine. So we start the machine like we start all of our other machines with an nmap scan. Although most of the time there's only one. What is that IP address? 172.17.02. So we're dealing with a different IP, with a different networking interface. So there's 2 ports open on this system, not just one. That's great. So the other thing we need to keep in mind is that our IP address for our attacker machine is going to be different since we're dealing with the Docker interface. So this is the IP address for us on the Docker interface. Okay, so let's take a look at what's going on here. So we've got port 22. This is probably not a vulnerable version of OpenSSH. A lot of people wonder like how you get a sense for what versions of software are vulnerable to known hacks. You just need to do a lot of testing, and then you'll get a sense of, you know, what is an up-to-date version of a particular piece of software. I don't think this is vulnerable. The other thing we need to pay attention to is sometimes the version of Apache that is being run is vulnerable. It's not usually the case. Narian, hello, or Narian, I'm not too sure how to pronounce your name. Welcome to the stream. Let's give you a Hack the Planet.
Hack the planet! Hack the planet! Shut up and get it!
Okay, so hopefully we're not dealing with the web application firewall, so we don't need to pay a lot of attention to doing, like, you know, different evasion attacks. Okay, so this is going to be our web app enumeration tab. Sure, that's how you spell it. Why not? Okay, let's give it a funky color. How about red? And let's just, because I want to get a sense for using the whatweb tool, we'll try running it on this. 72, is it 1702, something like this. So this should be able to get us some information about the web server. So it tells us it's Apache, it tells us the IP address, we knew that, and it's a default page. This doesn't tell us very much. We can run a few different tools to do web app enumeration. I like to use some old tools. I like to use derb. It's not a very modern tool, but if we're dealing with very old technology, the word list it uses is pretty good. So there's nothing here for derb. Could also run Nikto, which is another really old security tool. The reason why I like to run these first is because the syntax for running the tools are very simple, and I don't have to worry about really complicated looking syntax. Okay, I don't think we're getting anything with Nikto. That's fine. So the last thing we're going to run is a proper directory busting tool, and that's GoBuster. So we'll run GoBuster. We'll look for a bunch of different common endpoint file extensions. So stuff like HTML, PHP, TXT, zip, etc., etc. Halo CSS says, how long have you been studying and practicing cybersecurity for? Since the beginning of 2020. So I'm in my 5th year. But Halo CSS, hello, nice to see you here. Welcome to the stream. So yeah, I've been for and some odd years, I've been learning about cybersecurity. I still consider myself very new when it comes to cybersecurity as a whole, but I've been on my journey for a while now. So it's 172.17.02. Run the thing. Okay. GoBuster giving us crappy command syntax. Well, I mean, it is a more complicated tool, so we have to learn how to use the thing. So in addition to GoBuster, some people like to use FerrixBuster. FerrixBuster is okay, but it gets really messy really quickly. I find that running GoBuster it's good enough. If there's some other directories you want to look into, you can do those manually, or you can do those recursively afterwards. So we don't see anything here, huh? I guess what we can do is we can manually investigate the web page, because the automated tools are not helping us out too much. Okay, so this is Debian default page. Sometimes there are clues on these Debian default pages, especially in the HTML comments. That might be the case here, because otherwise... Okay, there's a lot of good stuff here. So we got a note from one developer to another. And we can put this in our Google Translate. Hi, Peter. Do you remember the books I lent you on steganography? Wow, way to give it away. Weren't they great? Here's a key that you'll use wisely at the right time. Please don't be so obvious. Life isn't about brute force. So... I mean, is this just a random password? How convenient. Well, I mean, you know, these are exercises, and exercises are meant to be solved. Just letting you know, I remember using this method because almost nobody else uses it, or maybe they do. Unfortunately, I forgot to. I just remember that it was basic. Well, I mean, if this isn't the key directly, then it's been transformed. So we need to figure out what encryption method or encoding method is used to create this. So what are the obvious choices? So the obvious choices would be, oh, I don't know. Although these square brackets are kind of annoying. This is not base64. The reason it's not base64 is because it doesn't really doesn't fit the character set. Yes is invalid input. What else could be going on here? Okay, so we also know that the name of the user is Peter. So we could try doing some brute force attacks. I don't know if this is what they want us to do, but we do have a user. So let's see. Echo Peter to users.txt. So here's the thing, we only have... So at this point, we could feed this into... Here's a key that you'll use wisely at the right time. So this is a key. Please don't CB... Okay, so life isn't about brute force. So we're not supposed to be doing brute force on the target. We're not given very much as far as this box is concerned. We got our SSH, and we got our HTTP, and that's it. We didn't get anything from... We didn't get anything from GoBuster, so GoBuster wasn't able to find any relevant endpoints. So the only thing we know is that there's some sort of steganography involved. We have a key, but we don't know where to use it. I remember using this method because almost nobody uses it, or maybe they do. Just remember it's basic. I mean, it probably means something. I just remember it was basic. Base, I mean, it's not base 64. It's not base 64, it's not base 32. Oh, there's probably another base system that includes all the special characters. So maybe it's like base 72 or something like that. Okay, so that was the note. Let me see if I can close out some more windows, because I need to clean up a little bit. Okay, so let's... Base 64, base 32, other schemes, base 85. Okay, so uses 85 characters to represent 7 bits per character. So, I mean, is there a base 85 command on the system? Base 85? Nope, there's no base 85. Maybe it's a hint at basic coding language. I hope not. I hope it's not about basic coding language. Let's see if there's a web app online for base 85. Okay, ASCII 85, base 85. So let's go ahead and we'll try pasting in our key. And actually, let's get the key first. So if you want to have a crack at this, I'll paste this in a chat as well. So echo out this thing, we'll call it the key.txt. Okay. I mean, we got this thing, we've got our web app here. So we'll decode. Okay, so we got 38 characters and codes to this. I want to do a little bit more research on base 85. And what the character set is. Okay, so this is ASCII 85. So characters used by the encoding text are I mean, it looks like it fits. Let's see. There's the ampersand, the equal sign, square brackets. Yeah. So, I mean, everything fits. When we use the web app to decode, then we get, what is this? Let's try decoding this new thing. What happens if I just keep on decoding this? I mean, if we keep on decoding this, it gets larger and larger. But I don't know if this is exactly how we're supposed to go about it, or if we're actually dealing with ASCII 85 at all. It could be another encoding scheme. We'll try asking the AI if it has any suggestions. Okay. I'm looking at a string that we suspect was encoded using a common system. Here is the string. We'll see if we can get some suggestions. You had ITR. ITR? Hold on. It was ASCII 85. You had it, it was ASCII 85. Well, I mean, let me get a suggestion over here. It's probably going to suggest ASCII 85 as well, but when we decode this from ASCII 85, Neems, hello, nice to see you here. What is up? We're just trying to figure out some encoding shenanigans. Have a hack the planet.
Hack the planet! Hack the planet! Shut up and get in.
Okay, you just had to switch it to decode and then enter the same ciphertext. Well, I mean, encode and decode just... Okay, so we've got... So this is the original key. This is the decoded version of it. We could try pasting in a few different rounds. But the thing is that even after we do a few iterations of ASCII 85, I don't see anything like super concrete coming out of this. Okay, Day says you just had to switch it to decode and then enter the same ciphertext. I'm not too sure I follow. Could you elaborate on that? You did it on the same website and got the password. Is this supposed to be the password? Let me grab that key one more time. So the key is this. Paste this in. And this is the encoded version, or the decoded version. So if we encode this this is the original key. We're decoding, and then we see the resulting text on this side. On the left, I'm getting v base 85 decoded password. Hold on. Did I just put it on the wrong side? Base 85 decoded password. Okay, well. Change the decoded to 80. So I guess I just put it on the wrong side on the web app. Okay, so if we wanted to do that like another way, well, I mean, okay, this is the web app here. I guess we could try to do it like to find some sort of Python method. Okay, so wait, did this looks like it could be base 64 encoding or some similar encoding scheme. Okay, well, I mean, I got it wrong. This could be modified base 64. It's not modified base 64. Okay, let me ask for something else. If we wanted to use a Python script to decode a base 85 encoded string, what's the simplest script that could do that? No worries, no worries. We got there eventually. Thank you very much, Day. I created a script that will try multiple common decoding. Okay, so that's it. It's just 3 lines of actual code. Import the base64 library, decode using base64.a85 decode, convert bytes with this. It's, well, let's try this out. Nano b85.py. Okay, encoded string, and then do the thing. So decoded bytes, run the script, and then we get base 85 decoded password. Okay, I mean we've got the password, but is this the password for the Peter user? Okay, so let's try logging in. SSH Peter at the IP address. Okay, that's not the password. So I mean, we need to use this on a steganography file, but we don't know what the, oh, you know what we could do? We could go back in and we could look for stuff that we could do steganography on. So if it's not any of these file extensions, we could look for JPEG, we could look for PNG, we could look for JPEG spelled the other way, we could look for GIF, and we might have better luck looking for this. So looking for JPEG, PNG, and GIF files on the server. Are there any suspicious... So steganography. So we know it's supposed to be some sort of steganography thing. There's only one file that we were able to find on the server. And it's this one right here. So could it be hidden in this graphic right here? Let's see. Okay, so this is... this one over here, this PNG file. So icons. So there is an icons directory. So the icons directory is here. Is there anything more in the icons directory? So it doesn't give us access because it's 403 forbidden. So the steganography we need to run is either on this PNG file right here, in which case we would just do some wgetting, or we need to search inside of that icons directory. Okay, I think I might have made a mistake. I made a mistake when I did my GoBuster the first time around. I forgot to put the HTTP in front of the IP address here. It might or might not really have some really big effects. Let's just wait a second to see this scan come back first, and I'll try doing the bigger scan. That includes HTTP in front. Bad Math says, amazing live, I subscribe, thanks for the content. Thank you very much, Bad Math. No worries, no worries. We're all here to learn, even when we're making big mistakes on stream. Okay, so there's this PNG file. We could start looking inside here. After this comes back, I'll start looking here. So this is the problem. When I did my initial GoBuster, where is it? You need to put the HTTP in front, otherwise it could all go wrong. We're going down a fun path. Hopefully, we will see. Okay, so we got index.html. Did I find that the first time? Okay, so what else do we have? So we downloaded this openlogo75.png. What steganography program do we run with PNG files? So depending on the file extension, it might not be the same. I think it's like zsteg. There's no zsteg command. Okay, let me look up. Steganography PNG files. Okay, there's also steganography online. Actually, let me just look for steganography tools. Okay, a list of resources. I've used this GitHub repository to look for steganography tools before. We're looking for stuff that works on PNG. So foremost, zsteg. Okay, to install it, gem install zsteg. Okay, I mean, I think I can remember how to do that. Okay, we've got... So the music stopped. Let's keep the music going. Gem install zsteg. Do we need to run that with sudo? Yeah, we need to run it with sudo. Okay, so try all methods, sudo e extract. This is the file over here. We can run exif tool first, just to make sure that this has got its regular stuff. So zsteg a file runs all the methods on a given file. E is extract the data. Extracts data from the given payload. So I guess we would try zsteg-e. Zsteg options filename.png parameter string. Extract specified payload. I guess we could try all instead. Okay, so sometimes there are messages hidden in the steganography here. In this case, I don't think that's the case. It's reporting that there's some sort of secret key in here. I don't know if that's actually true. How large is this file? We weren't able to find anything. Let's try looking inside the icons directory again. Okay, we found icon small. It's good. Let's see if we can directly access that. Still forbidden. So we got icon small. We can try looking in there next. We could also try looking directly in there for JPEG files, image files. Okay. So we've got the PNG file. We could try using foremost or binwalk to see if there's anything hidden in there. No, foremost is a pretty good tool. So let's go ahead and install it. Okay, so let's try it again. So it copied to what directory? Output directory. Let's take a look in there to see if there's anything. PNG audit.txt. I mean, it's still just a PNG file. Okay, so we're kind of running out of stuff to look for. Let's try a UDP scan. We usually don't like to do UDP scans on targets like these because, well, it's UDP scans are not very reliable. We'll just do the top ports, the 100 top ports for UDP on the target, and we'll leave it running for a little bit. I think you need to do sudo to run UDP scans. Okay, what's going on with the web enumeration? So we found the small directory. We'll try looking for JPEG files, PNG files, and GIF files. What other media files could we try looking for? Server status seems to be the move, likely going to be have an API if it's abusable. Well, I haven't really paid too much attention to server status, but it's 403 forbidden. Most of the time it's 403 forbidden. I'll hit it up in the browser here. Yeah, so that's forbidden. So there's no Peter directory. Could there be like a steganography directory? So the landing page, let's take a look at that landing page again. Let's see. Okay, we got our key here. So they talk about steganography, so we could try using this as like a directory to look inside of. No, how about .html? How about .php? Yeah, we could also try looking at curl. You're right. What? Why are we getting so many image files? Is this normal? Hold on. Okay, I just want to get the basic curl stuff. So curl this thing, head that. Okay, so there's nothing suspicious in the HTTP response here. What's interesting here is that so many of this stuff actually came back. If we need to download all these things and then look manually inside of each one of these files, that's gonna be a big pain in the butt. Let's try looking in the small directory as well. There's a bunch of stuff in here too. Okay, so there's a bunch of image files in here. We know we're dealing with steganography in this case. My bet is that we're actually trying to look at the largest files. But I don't know. Xmetric says, looks like a file browser default stack of stuff. Yeah, probably. Well, I don't know. I don't know. Okay, scanning a bunch of services over UDP. We'll see what comes back in a couple of minutes. So we could actually create a list. We could create a list over here. We could download all these things. Now, how do we do it? Okay, so I mean, I can create, this is the small directory. Let's create a list. Nano, call this small contents. Okay, we need to format this correctly. What was it? cut delimiter slash first field 0 field. Okay, so these are endpoints. Regex to the rescue. I sure do love my regex. tr delete all of our spaces and output that to small dir.txt. So we could try downloading the stuff on this list, and we should probably make one for the other endpoint. So the other endpoint was just icons. Okay, so I mean this is more likely to be what we need to be looking at. So Apache pb.gif, I mean I'm eyeing the larger files. And then afterwards we'll find some way to recursively download all these things. This will be done in about a minute or so. But in the meantime, is there anything else that I should be paying attention to? There are no other directories that are being referenced to on this page. Yeah, just the icons directory. There's also a manual directory. Probably can't directly access that page either. Okay, let's try going to manual. Not found. Okay, we've got our list here. Let me just create this. VGAH2O. That's a great name. Thank you. Thank you very much for following. Okay, copy this. Make this contents.txt. Save that. Cat it out. Then we need to format the stuff with, what was it? Cut by space, return field 1, trim out the white spaces, okay. Oh, oh wow, VGAH2O has subscribed with Twitch Prime. Everybody, do you have Twitch Prime? You can subscribe with Twitch Prime using your Amazon Prime. There's a link to figuring out how to do that. Thank you very much. And thank you very much, VGAH2O, for subscribing. Let's give you a Hack the Planet.
Hack the planet! Hack the planet! Shut up and get it!
Okay, there's a little ad going on Twitch right now, so I'm just going to put on some birds. We'll be back in about 30 seconds. Just need to have a little bit of a water break. Oh, those wacky birds. Okay, let's put the birds away, get back to the hacking. Alright, so we got these two lists. We need to download these files. Let's see, how do we do that? So wget download from list of files. Okay, to download files using wget from a list of URLs, you can employ the -i or input file option. Create a text file. Create a plain text file, urls.txt, and list each URL that you want to download on a separate line. Okay, but the I don't know if we can. What happens if we want to prepend something? I guess we could prepend. We could prepend to the list by using some sort of fancy Linux tools as well. You need to concat the file first. Yeah, let's so the base URL is http 172.17.02. We need to. How do we prepend this to all the items on the list, or all the lines on the list? So this is usually something I would ask the AI for. So the AI asks the question, we want to prepend some string to the beginning of every line in the file using Linux. So it's probably, yeah, it's probably sed, SED. So sed is the most common. Sed something something, your prefix, input.txt, output.txt. Okay, I mean, that seems simple enough. Let me grab that. Okay, so that's... Hope this works. Character 11 unknown option to S. Did I do this incorrectly? Your prefix. Oh, okay. We could use awk. You got, use Perl. S is going to substitute command. Matches beginning of each line, your prefix. End pattern. Oh, okay. It's because of the slashes, I think. How do we escape these? Is it backslash? Hold on. With the sed command, we want to include slashes in the pattern. How do we escape those slash characters? Okay, so it's we just need to do a backslash before each one of the slashes. In the prefix, you need a backslash before the slash. Alright, let's try it again. Backslash, backslash. Okay, so it works. So now we can take this list and then we can download it with wget. Let's see. Let's move inside a directory first. We'll call this images. And we'll move the list in here. What did I call it? Oh, we called it modder. Now you have 2 slashes. It's awesome. Okay, so we've got our URLs. So we just need to do wget-i, and that's it, right? 404 not found. Did I get trolled? Oh no, it's inside the icons directory. Never mind. Okay. Hold on. So I need to put the icons directory in there. IR Haxor, of course. If you don't let's try that again. Okay, so it's okay. Let's take a look at the thing again. Oh no, I included an extra slash. Okay. Unterminated. Okay, let's try that again. Okay, now it looks okay. Let's move into okay, now we've downloaded them all. We have all of these files. Now all we need to do is run steganography on all of these. So these are GIF files and they're PNG files. There are no JPEG files. Now we run through them one by one. I would not like to do that. Man, how do we do this recursively? We should probably come up with some sort of script. The other question I have is what did we with zero scripting? How do we do with zero scripting? Bash scripting, maybe. So what's the steganography tool we use with GIF files? Let me take a look here. Set list. There's nothing here that covers GIF. Or just browse the images for a quick glance. Browse the images? I mean, I guess we could. The thing is that that's the PNG image, right? You can tell it's a PNG because there's transparencies. Look into the find command. It can exec commands for each thing it finds. Yeah, I think it was some. Well, there's also the zargs command, right? Zargs, xargs. The find command could also work. I'm not too sure what we would be looking for. We could run it on all the files, yeah. Watch it be something dumb, fully transparent, except for text written in EFEF. That'd be so fun. That'd be so fun. Not really. Let's just try the largest files first. So the largest files are going to be these ones over here. Hopefully I don't need to. Here's the thing. Most of the time when we're doing steganography, we're doing it on JPEG files and not PNG files. But the only tool I know for PNG files is ZSteg. Let's try opening this largest file first. So powered by Apache. Oh man. Okay, so I'm not too sure which steganography tool to use with GIF files. Let's look it up. Samaria says steg expose, for example, provides a confidence score indicating the likelihood of steganographic content. Steg expose. I mean, I've never GIF shuffle. Let me see if I can look up that tool called steg expose. So this is a GitHub repo. Specialized in detecting LSB, lossless images such as PNG and bitmap. We are dealing with PNGs. Okay, can be set to default or fast. Samaria says GIF, Java. What are we doing? Basic use of steg expose, providing a directory of images as the only argument. Java jar steg expose .jar test folder. Well, we've got. So how do we install this thing? Java stuff. To compile the source code and create a new executable jar file, the following commands will do the trick. So I guess we need to clone this repository first. Then we need to git clone. And then we need to run the commands. So, I mean, they give us a couple of commands we can use to compile the thing. To recompile the source code and create a new executable jar file, do we need to recompile this, or can we just use whatever we downloaded from the repository? There's already a jar file in there. Okay, let's take a look at the sample commands. Java jar stegexpose.jar test folder. Stegexpose.jar is in here. Okay. Test folder is going to be tmp images. It thinks that all of these things are suspicious. Or does it actually think that all these things are suspicious? I mean, it just tells us these things are suspicious. Do I need to do some additional... Produce a steganographic report in a form of a CSV called named steganalysis of test folder. Update the threshold and run the program in the fast mode to save time. Just try to run it. No outliers. Test folder default. Okay, let's give this a try. Go into files with bigger values, but it's all about 20 bytes or so. I mean, they're not all... Bomb.gif is suspicious. Well, I mean, there's some that are larger. Compressed.png? Huh. I mean, this is a pretty likely candidate. It's called compressed.png. It's got a bunch of hidden data. I don't know. Okay, let's move into... We'll try running foremost on it. There's nothing in here, though. Decompression key? No clue. Okay. Let's think about this for a second. So if we were to run zsteg on compressed.png, this doesn't show us anything. Now, how do we do this? How do we do this recursively? I guess the other thing we could do is we could start looking for other types of media, because it's not necessarily just image files that could be using steganography, because it could be music files and it could be video files. I've never really dealt with image files or music files, for steganography before, but it is possible. Okay, Pebble says you could do a -A star. Which command are you talking about, Pebble? Welcome to the stream. Everybody, Pebble is a InfoSec streamer person. Let's give Pebble a shout out. If you want to do advanced cybersecurity CTF exercises, you can check out Pebble's stream. Pebble usually streams on Sunday, and they're usually doing Windows Active Directory difficult challenges. The last command where you did it on one file, change the file name to star, and you should do them all. I mean, if that's the case, hold on. Let me go to another tab. Okay, so we would do zsteg on everything. Well, I mean, this... okay. So zsteg-A on everything? I mean, let's... okay, if this is the case, we should probably output this to something. And thank you very much for following Bretsky003. Welcome to the stream. Let's give you a fun video redeem. How about some Nyancat? Let's call this output.txt just for fun. Okay, well, I mean, so after this is done, we're just going to have like a ton of output. The problem is I'm not too sure what I would be searching for. Maybe like something like key or steg or something like that. I'm not too sure. It's just a lot of stuff to look for. Gotta wait for this thing to finish first. I thought it would be easy after we managed to decode the key. Actually, you know what? So we decoded the key using some sort of web app. Where is it? No, it's in ASCII 85. Hit it with strings. Strings? Yeah, I mean, I suppose we could hit everything with strings as well. Hold on, let me go over to... Okay, so we did our UDP scan here. And yep, it is very vague. Doesn't help at all. Just your output file to filter some junk. Where's the key from? So the key is, let's see, scat key.txt. So we got this from some HTML comments, and this is actually, it's actually written in base 85, which is like base 64 but with 20 more characters. So if we run this thing through base 85, we discovered this password right here. Let me just copy this somewhere first. decoded key.txt. HTL comment is the hint. We decoded an HTL comment. Yeah. So it was actually on the landing page. So in the web app, on the landing page is all this stuff addressing somebody named Peter, and they're talking about steganography, and they're talking about a key, which is this thing. First line. Yeah. So did we finish with that command? Where did we do that? Here. It's still going. Is it still going? What directory? So temp images. Let me take a look in here. No, it finished. Mac binary invalid date. I mean, I'm not too sure what we're looking for in these files. We'd have to grep. We'd have to start grepping for some patterns. Hello, Peter. Yeah. I mean, we got... Oh, we could start looking for Peter. Yeah. No Peter here. We could drag strings on all the files and grep for Peter. How do they spell Peter? Peter. I mean, I guess we could grep for insensitive. Warning output is a directory. Let's strings recursive. Can't strings recursive. What's that file name? That's the file name? What are we looking at? There's also... So strings doesn't work when there's directories involved. I guess we can just get rid of the output directory and then it should work okay. RMR output... And there's no other directories in here, right? Yeah, okay. So we should be able to run strings now. Nope, didn't find anything. I guess we could also run exif tool on everything as well. Okay, and then... Oh, wait. It says xml.png binary data? Hold on. It says this about most of these. So binary data, 9 bytes. Binary data, 15 bytes. Hello, Peter. It's like a line from Spider-Man. I don't know about... Let's see if we can... grep for Peter in this case. Nope, no Peter here. Okay, so binary, I mean, this amount of binary data seems to be pretty big. Actually, let's run exif tool and then grep on binary. So this just lets us know the size of the binary data. So palette transparency. These files in particular seem kind of large. This one is the biggest one. Let's zero in on this one. Where did I get the images from? I got the images from the icons directory on the web server. Okay, so grep that, get the surrounding 20 lines. So what's the name of the file? It's called, this is compressed.png. So palette and transparency, use -B option to extract. Can we use exif tool to extract? I've never done that before. So this is compressed.png. Okay, you should look into the FTP server. Okay, so let's try exif tooling this thing. We'll use the B option to extract. And I guess this is just... So the compressed.png is kind of suspicious, but the last time we inspected it, it didn't really have anything. Let's just run zsteg on it. What else could we do to this thing? Not the droids we're looking for. I don't know. I mean, I don't know. Okay, so zlib compressed data best compression. Zlib compressed data. What? So binwalk -E to extract, right? One more files failed to extract. We'll try foremost. So we got this zlib file. Target VM has FTP server running. FTP server? Did I miss something really big? Hold on. Okay, let's nmap this thing again. Oh, need to specify that I'm not doing UDP. What? Why didn't I see port 21 before? I feel dumb. I feel really dumb. Hold on. With anonymous login, Sumeria 1. Wow, thank you. Thank you very much for pointing that out to me. Jeez, I didn't know. When I did my first nmap scan, I didn't get this. I didn't get port 21. What? How did... Always run nmap twice. Always run nmap slower. Always run nmap twice and run it slower the second time you run it. Otherwise you miss out on stuff like this. Okay, let's try FTPing. It's got anonymous access according to Sumeria 1. FTP this thing, anonymous. Hello Peter.jpg. Why were we... so dumb. So dumb. So dumb. Get that thing. Hello Peter.jpg. Dumb. Okay, Let's do steghide. Steghide, hello Peter. It's not installed. We should install it. It'd be like that sometimes. Yeah, unfortunately, yes. Thanks for the emotional support, everybody. Okay, steghide. Unknown. Steghide info. Okay, so we know the passphrase. It's... what is it called? B85 decoded password. You find me.txt. Okay, well, we can extract now then. Is that not how you do it? Wait. What is the command? Extract, okay, so... and then we have to do SF for stego file. Enter passphrase. Okay, so you find me.txt. What? What is this? What the heck? Okay, so this is some sort of code. So is there like an ook, like a cryptography method? Let's just feed this into the AI. It might know about this form of encoding. What do you make of this message? The periods and question marks? Could be. Oh, okay, so it's an esoteric programming language. Right. It's basically another type of brain love. Using 3 tokens, ook, ook, and ook. Decoding it, you can decode ook with online interpreters and tools. Sure. So I mean, decode.fr is a favorite of ours. So we can plug in ook and then execute the ook interpreter. What? Hold on. So this is I mean, is this just a string? If this is just a string, this is probably the password. This is either a password or a directory path. Let's try this as a directory path first. Then we'll try it as a password. It's not a directory path. We'll try it as a password. That's not a password. So the other thing we need to do is we need to double check the contents of the file. So Ola Peter ook 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 ook. Okay, let's copy this. We'll also ask the AI if they can just interpret it. Please give me the translated message. So Mary says, wait. Yeah? Which string did we get? So according to decode.fr, where is it? Let me close out some of these tabs. this should be the output over here. Was it in the directory? I mean, it was in the directory also. You find me.txt. Okay, so let's see what the AI has come up with. Is it still running? No, it wrote me it wrote me code. Okay, so we also have another online decoder. We'll take a look at this as well. Obfuscation encoding, great. So it's like text to ook to text. So ook to text. Paste in this, ook to text. Yeah, so this is the same thing we got from the other website. The other website, it's some sort of string. But, I mean, do we take this at face value? Or do we think this is this is still encoded? So if it's still encoded, is it base 64? No, it's not base 64. Is this, I don't know. Is this time? So 9 hours, H for hours, and S for seconds? Hint decoded wrong. Wait, Sumeria, do you have some information that we don't have? Have you been looking at the write-ups? Okay, so can you paste the ooks in chat? Yeah, let me do that. This is gonna look really good. So good. And professional write-up backseater. No worries. That's a lot of ooks. All right, so let's try doing it one more time. We'll try logging in with this password one more time. What about ook? Isn't it truncating? Oh, is it truncating? Sorry, if it's truncating, let me get you. What is it called? Paste bin. I'll paste bin it for you. Okay, create new paste. Oh, need to make sure I'm human. Okay, so this should be it. Here you go, everybody. Okay, so that's not the password. That's not the password, at least not directly. Let me make sure that these are both the same. So 9H889 9H889 HHSS23 HHSS23 23H. Yeah, so these are the same. So I mean, is there in argument? So when we say argument, is this like some sort of key? So if there's some sort of key, I'm not sure. It's like hello Peter something something. Like hola Peter. I mean, it results in the same thing. Add hello Peter to the top of the decode. I mean, the thing is that I don't think it changes anything, because the only things that are accepted are the versions, all the ooks. So ook with a question mark, ook with a dot, and ook with an exclamation point. BF book. Yeah, let me check out that website. Just a second. Samaria 1. Okay. All right, let's take a look. Does the ook and ook, it's like a programming language. Okay, so ook is enter your code or text here. I mean, sure. Let's include the Ola Peter. I don't think Ola Peter modifies anything, but text to ook. No, ook to text. Ook to text. Yeah. So I mean, we get the same thing. This is the same interpreted string. What how? Is there anything else we can do with this? So we need to interpret this somehow. So I see the H's and the S, and I think that this could be maybe without Peter. I mean, I'm pretty sure it's going to be the same thing. So it's 9HSS23. Okay, Lee execute 9HS23. It's the same. Sumeria says, I got a different decode. Did you get a different decode? Did you do ook to text? Or did you use ook to short ook? No, I have no idea. Hold on. Option ook to text. Okay, ook to text. Execute 9H something something 23. Did you get something different, Sumeria? So the other thing we could do is we could try FTP as Peter. This FTP server is anonymous only. Login failed. Okay. Oh, okay. So you got the same. You got the same result. So I mean, we just need to. Okay. Let's make sure that there is no extra files in here. So hellopeter.jpg is the only file in here. And let's just open that thing up regularly. Okay, yeah, that's great. Not 23 at the end. Not 23 at the end. Wait. You got the right result. Not 2-3 at the end. Are you saying that this is 2-3 is the borked one, and HSS2 is the correct one? Did I paste it in? I mean, it could be that I pasted it in incorrectly, because 2-3 is what I've gotten for all this stuff. Yeah, this one's 2-3. And this one is also 2-3. So what am I missing? The different payload is literally one symbol. Oh, is it because there's exclamation point here? I did it and got it without 3. So did you include the Ola Peter? Did you include Ola Peter? Hold on. So let's try it with Ola Peter here. 2-3, and then we try it without Ola Peter. Execute it again. Still 2-3. I copy pasted from pastebin without Ola Peter. Okay, let's try... Wait. There's another thing called short ook, which interprets dots, question marks, and exclamation points. So if we include the entire message and we do it to short ook instead, which sounds really, really weird. So short ook to text. Message will be encrypted here. What does this mean? We need to strip out all of the letters then? Okay, we'll go on for another 30 minutes or so, and then after 30 minutes we'll we'll reevaluate if we want to keep going. Okay, so let's see. So a variant of ook is short ook, where the ook is stripped out, leaving the following commands. So let's strip out all of the ook and all the letters. How do we strip out letters? So let's just say, so message.txt, this is all the stuff. If we wanted to eliminate all of the letters in the message, how do we do it? I'll ask the AI about this. XDD, just vim replace ook with // And thank you very much for following Juicy Delicious. That's a fun name. Let's give you a video redeem. How about some Stellar Jays? So this is my favorite bird. Okay. How do we strip out all uppercase and lowercase letters from a file? Okay, sed something something removes all letters. So sed remove all letters. tr delete letters. I mean, it basically does the same thing. Let's give this a try with... Okay, so this deletes everything but the symbols. We also want to get rid of this comma, because the comma doesn't mean anything. So tr delete commas, and then tr delete spaces, and then tr delete new lines. Okay, so this is all we have left. This is all we have left. Okay, let's see if we can translate this from short ook. Where's that? Can we undo all of this if it's wrong? Yeah, we certainly can. Short ook to text, execute. Mismatch bracket, extra right bracket. Wait, there are brackets? Mismatched brackets, extra right bracket. I guess the brackets are created by... Oh, okay. Well, it comes out to the same thing anyways. Alright, well, this is what we have. We translated the message from ook and got this string. Does it mean anything? Hexadecimal. Hexadecimal? No, there's no way this can be hexadecimal. There are no S's or H's in hexadecimal. 9H, 23H. This is hexadecimal notation? (9H) SS might be letters or another encoding. 23H. I don't think... Yeah, this is from a Stego challenge from a CTF. Let's just say that. This is part of a longer message. So there's an H and there's an S. All right, I need to take a little water break because this is driving me crazy. Let's put on an ad. Let's put on my favorite video, and I can feel a little bit better about myself when I watch the baby birds have a little bath. We'll be back in about 60 seconds. Enjoy the birds. Okay, we'll be getting back to the hacking in just a few seconds. But isn't this the cutest baby bird? I think so. Okay, let's put him away. So the HH and SS break the pattern. They could be delimiters or special markers. So this is most likely interpretation is hexadecimal notation. Hex value 889 out of ASCII range, or could be this. This is a challenge from steganography challenge So these could be coordinates, header and stop, no idea. So the only thing I could say is that the creator used the tool I gave you and also got the results that you are. What did we end up using the base 85 decoded password to do again? Yeah, so when I'm adding 23 at the end, but you didn't get 23. Yeah, I mean, let me, okay, so Day asks, what do we end up using that password for? So the Hello Peter JPEG file over here, this had a steganography file embedded in it. We used the steg hide tool to extract it, and we needed to use the base 85 encoded password to get access to this. So long story short, we use this the same way you used the previous one. Okay, well, if we can skip over to the next step, that would be great. I can only assume that we're supposed to log in with Peter's password. This is Peter's password. So I don't know how I got that extra thing. Okay, before we move on, I mean, this doesn't feel very earned, but you know what? Let's... So, Ola Peter, right? This is the entire thing here. And we'll try feeding this into the other tools. So the other tools are this. Text to text. Okay, it doesn't work. It didn't work because there's, well, probably because of the Ola Peter. Text results in this. Let's include with the extra exclamation point. Text. This doesn't work because there's too many. Maybe you need the first one. I don't. It doesn't work. Well, this tool doesn't work if you text this. It just breaks. If you use this tool here, and get rid of this argument. Says it this errors out. So Sumeria, when you use the tool, did you include the Ola Peter or did you omit the Ola Peter? Okay, it says that this is invalid. It's... I need to reload the page. Okay, so we'll just get rid of Ola Peter. Why did we paste it in multiple times? Yeah, it gets it. It interprets it with a 3 at the end. Add one more thing at the end? Maybe. Okay, let me try it. Let me try it one more time. So this is with Ola Peter. We'll add an extra exclamation point at the end. No, this doesn't work. I'll look it up later. Let's try to finish the box. We got 17 minutes. We might be able to get it done. Who knows? Where are we? Okay, we're Peter. Important notice. So files and important notice. Is this Peter's home directory? Yep. So we got files directory and we got important notice. Nota importante. What? Let's translate the message. Do not reboot the system. There's an important file in temp. That's really funny. Sick in the mind. Hello, nice to see you here. We've been having a heck of a time with this box, doing all sorts of weird CTF-like stuff. So there's an important file in temp. What is this? So there's a root file, something for sysadmin. This is where our AI translation stuff. When I was a kid, I remember converting videos from FLV to MP3 just by changing the extension. How naive. Converting videos from FLV to MP4. And what is this other file? So this is, I don't know what kind of file this is. So ODT files are, anyways, let's try transferring this over to our other system. So it's an Office file. ODT is Open Office, right? Okay, let's see how large this file is. It's not that big. We could probably move this over with the clipboard. Okay, let's do that. So the weird file is zip archive data. Zip archive data. Okay, what's good, Shy Hat? Which box is this? So this is Fileception from Dockerlabs. So Dockerlabs, this is a medium level challenge. It's called Fileception. Okay, so this is I mean, it says it's a zip archive. Zip archive data. So let's unzip it. Very good, lab. I don't know about it. It's been bugging me a bit, but I guess the best labs bug you at least a little bit. Hold on, let me change up my music list. We'll end off with some good old Faster Than Light. Okay, so what do we do? Let's turn this into a zip file. I mean, it says it's a zip file, but I don't know for sure. So we'll try unzipping it. Okay, so this is... configurations to accelerator, floater, bitmaps, toolbar, XML, content XML. We could try looking for stuff in we could start looking for stuff like passwords in here. So grep recursive for password. We found a password. Look, everybody, we found a password. So this looks like base64 encoded. So echo it out. This is just a bunch of numbers and... Could this actually be a password? Okay, so we've got our... What other users are on the system? So there's Peter, there's Octopus, and there's Ubuntu. So we found this in importantoctopus.odt. So this is probably the Octopus user's password. Switch user Octopus. Okay, now we're Octopus. Just become root. just become root. We're root. Yay. All right. Let's enter the root directory then. Done. So second in mind, the command is redeem I'm root.
What are you?
I'm system root.
Just become root. That's all you got to do. Who knew it was this easy? Okay, so this was a heck of a ride. Okay, so there's nothing really in here. I'm still on the ook memes, making this with the encoding. The difference is ook, ook, ook. How did I screw that up? Is it because I downloaded it without the binary mode? But we didn't. It wasn't a binary mode file that we downloaded though. So I'm not sure where we got the extra stuff in the ook file. Yeah, that's weird. Let's see if we can find where that file is. What was the file called? Oh, actually the file is in the FTP directory. It could have been like the way that we extracted the file as well. Different tools gave me different results with the same pass. It looks like ook is not production ready language yet. Maybe, yeah, maybe not. Let's move into the var www.html directory. So there's nothing here. So the only thing is the message here. You know, I did learn some stuff from the box. I learned that, let's see, what is it called? Base 85 is a thing. I didn't know it was a thing before. And any box which teaches you something it's a good box. Although there is some really frustrating things about this box as well. Actually, you know what? This box wouldn't have been frustrating if I'd only learned to run my nmap scan more than once. Because the first scan really didn't tell me about port 21. Would have been infuriating without the write-up. Yeah, I should take a look at the write-up to see exactly what I missed. Okay, so let's talk a little bit about what we're going to be doing next stream. So we're going to be switching up our HackerFrogs AfterSchool topic next stream. So if you've been looking to learn about web app hacking, then this is the stream for you. Because we're going to be learning about all sorts of web app hacking stuff in the next class. So batch 1, this is the last course, and it's 8 sessions long. we're going to be learning about robots.txt and directory listing. It's so if you know absolutely zero about web app hacking, we're going to be starting from absolute zero, and we're going to be working through some levels over at the Not a CTF game. And we've got a bunch of stuff over at Pico CTF as well. Dave says we did most of it without the write-up. Yeah, I need to figure out what exactly went wrong with the ook thing, because we weren't able to get that done. And what else are we doing? So this is Linux Monday. This is done. Web App Wednesday is going to be on Wednesday. We're going to be playing our favorite game, Hack the Web, which is our favorite German cybersecurity CTF game. We're going to be doing HackerFrogs AfterSchool Web App Hacking Session 1 of 8. We're going to be learning about cross-site scripting with the Darn Vulnerable Web App over at TryHackMe. And we're going to be doing some scripting challenges over at Alla Cyber. We're going to be doing the web app challenges over there. So please look forward to that. That's going to be on Wednesday. So as for right now, let's see if we can find somebody we can raid into. So let's see. InfoSec streamers. We've got Hetanis. Hetanis is online. Who else is online? CyberNoipi. Let's see. Any FFUF room in THM that I can practice on? You know, we can help you with that. Sure. Let's go ahead and look for something really quick. Tryhackme.com. There's also stuff on Hack the Box Academy. Let's see if I can find it for you really quick. So Hack the Box Academy it's a very good resource. It's not the most beginner friendly stuff, but the platform isn't super beginner friendly. The materials are very good for beginners, but it's not. How do I put this? Okay, let me log in. Let's see. Let me get my credentials. There's FFUF, enumeration, fuzzing, and stuff like that. It's not free. Oh, okay. Hold on. Let me get my academy. My academy login. We're looking for emails. See if this works. Those are not the credentials. Okay, hold on. I got so many of these logins lying around. Just a second. Okay, I think this one should be okay. Penguin Burger Meal says, "You're still streaming?" Yeah, we're going to be streaming for another couple minutes or so. I just want to help somebody get some materials. Why is the web application so slow over here? Okay, let me see if I can just Google it. Let's see. HTB Academy. I think there should be like a module called FFUF. Attacking web applications with FFUF course. This is a course. Okay, so I mean, is this... Come on, let me log in. Okay, now we're logged in. We'll look at the modules. All modules. And we'll look at the tier 0 modules, because the tier 0 modules are the ones that are free. Okay, so I think this one might not be... Well, I mean, there is web fuzzing here. Yeah, why don't you take a look at this? It's not necessarily FFUF, but you can probably do all the stuff in here with FFUF. Here's the module. Here you go. Okay, so I hope that that helps you out, Cybernoipy. So aside from that, I don't know if there's an FFUF. Try hack me. Yeah, I think let's see. The problem is that it's probably not free. Save her out all of the out context pastebin links. Yeah, I think I've still got the pastebin link. If where did I put it? And I should probably be able to find it in the chat somewhere. Okay. Yeah, this one right here. Cybernoipy says, "Try hack me. I have premium. I don't have hack the box." You don't need to have a paid subscription for hack the box. So this one's a tier 0. Wait. Yeah, so this is a tier 0 module, which means that you don't need to. Well, you'll earn back your cubes when you complete it. As for try hack me, but you need to spend the cube things. I think you get like 50 cubes when we get 50 cubes when you sign up. So as long as you don't, let's see, FFUF. There's a room here. Is it free? I don't even know if this is free. Let's try joining the room. Join room. Yeah, I mean, try this one out, Cybernoipy. I mean, I really like FFUF. I try to use it when I can, when I'm trying to fuzz for stuff. Anyways, what were you doing? We were looking for somebody to raid. Let's see who's on Twitch. Okay, so it looks like Moohiddles is online. So we like raiding into Moohiddles. Moohiddles is a really cool person. Let's see what they're doing right now. Hope you do some FFUF rundown sometimes. I mean, I do use FFUF a lot. Maybe one of these days. One of these days I'll talk about a lot more Moohiddles. Sorry, a lot more FFUF. Let's raid into Moohiddles channel. Raid Moohiddles. Okay, everybody, we'll be back on Wednesday. Hope everybody has a great rest of the week. But until next time. Oh, remember to give this message when you arrive on the stream. OSFrog, hip hop hack, OSFrog, just like this. And yeah, we'll see you next time. Everybody, we're raiding in 3, 2, 1. HackerFrogs out.